And we're alive so far. Let's see. And Martin Eastburn is the first one to log in here.
Sounds like we're waiting for that expressway to collapse again.
Which expressway?
Yeah. That was really some kind of a day, wasn't it?
Wasn't that something? I'll never forget that.
You could never make something like that up and believe it the way that happened, you know.
Especially that girl that on the bicycle.
And I think they called out 45 seconds or something like that, and she came flying past right down toward the explosion site.
Yeah. Yeah.
Good evening, gentlemen.
Good
Hello,
evening.
Adrian Bradley. Hi,
Yes.
Adrian.
So, my apologies, I wasn't able to make it for the WAS meeting yesterday, but I'm here today with my Summer Sky Milky Way shirt. There's absolutely
Nice.
nothing else on the side of the shirt, but in back is a beautiful Cygnus region, which I may or may not be able to show off because I can't tell if I am. So, yeah, trust me, it's the Cygnus region, and beautiful rendition of it.
That is a good piece of Milky Way, Cygnus.
Yeah, and I think sometimes overlooked by the if you look at a lot of the beautiful nightscape artists, it's the northern hemisphere Milky Way rising or Milky Way core standing up or slightly fading. Then it gets cold, and that's when I think maybe more attention ought to be paid to the what the night sky does and changes. You've got the Orion region, which a lot of folks are starting to discover and use astrophotography skills with, because they're taking a lot of multiple images of the sky to get all of that HA data and all the nebulosity in that molecular cloud out, and then they're lining it up with the with some beautiful foreground mountains or a lighthouse. And I've done similar. So I think it'll be time to evolve and show off Cygnus a little bit more with some of this photography, and just show how beautiful each part of the region of of the Milky Way is, not just the core. And Lacerta, I think, is where a lot of you have Cassiopeia, Lacerta, and Cygnus, and that area can be beautiful. And where I went in Alcona, it was very visible. So it was that's one of the goals I have, is to do that. But I also, the core is coming back, so prior to sunrise, the core just gets up over the horizon. So I have a goal of shooting that again.
Hey everyone.
Hi, Karim.
Karim.
This is really wanting to congratulate you and your daughter on what you're doing with the with that upcoming lecture that she's going to give this weekend.
Thanks. We're excited. And the club is really starting to form. Nathan and Bella and Vince, and they've really they've got good ideas. They've got some really good motivation, which is great to see. And Scott's giving them a lot of support, which is amazing.
I think that's wonderful. But
How are you, David?
Dina wrote to me that she says that bringing you on board is possibly the best thing that's happened with this group.
Awesome.
Oh, that's so nice of her. No, she got the ball rolling. I'm just trying to help with a little bit of the organizing.
Yeah.
And it's
Adrian,
great.
hey, David.
Young people from
How you
around the
doing?
world will join in,
Yeah, Dina was saying that we've got some good numbers coming into the registration now, and it seems to be coming from all across, not just North America, but even a few from beyond. So
Nice.
Great. I'm looking forward to that. It's the 13th, isn't it? Or is
yeah, it's on Sunday the 13th.
Sunday the 13th? Yeah. And I'm planning to be there.
And are you going to start us off with the small reading?
A very small reading. Dina wants
Now, what
to be
time?
as short as possible.
Now, what
Short
time
as
is
one
that
I've done.
again?
It's only for youth, unfortunately, Adrian, and it's not for young at heart. It's for the actual young. So I don't even get to participate.
Okay. Well, here in the States, that's also Super Bowl Sunday. So
Well, this is our thought, right? This is while the adults are tailgating, the kids are drawing aliens.
That's right.
And we're done before the game starts. So it's perfect.
Oh, that works. That works out perfectly then.
I think it's a great idea. And I think this is going to work out very nicely. I'm looking forward to it.
Yeah, looking forward to seeing how some of it turns out.
We're hoping to share it on either next week or the week after's Global Star Party. Maybe not next week because we've got Galileo's birthday and we're going to be having lots of fun with that, but maybe the week after.
That's right.
And as well, Scott has kindly agreed for the kids to have a section in the next Skies Up for their club. So we're actually going to have a kids section coming out in Skies Up now.
That is a great idea.
I think that's going to be a lot of fun. We're going to come up with a few different things for them.
Delivery guard command has been accepted. And we are slewing to the burn attitude. "24 minutes duration. And confirm slew target is -0.8 sun pitch. All stations Delta P on off. 2-minute warning. 2-minute warning. 1 minute until burn execution. ACS has entered Delta V mode. And burn is underway. 5 minutes remain. Gas chambers have been disabled. CS is 299 and 385. Over temperature monitors are active and in a delayed state. Under 2 minutes remain. About 1 minute remains. Next, we'll see the update to the ephemeris table and determination of SCS 299 and 385. Ten seconds remain. We should see all of those items executed, and then we'll be in a relative time delay of 200 seconds waiting for rates to settle before it transitions to normal mode. And burn is complete. Ephemeris has been updated. SCS 299, 385 have been terminated.
Hello, John. Good to see you.
All stations, we have entered normal mode. Valves have been disabled. All right, all stations, we are currently in a 3-minute hold, and we will begin slewing back to our intermediate attitude via SCS 422. That slew is expected to take 24 minutes.
Mm.
1 minute out from starting our slew via SCS 422. And we've started our slew. Stand by for duration estimate. -23 minutes slew duration. SCS 421 has been terminated, and we are currently executing in 422.
Hey, everybody, it's Scott Roberts from Explore Scientific and the Explore Alliance, and this is the 82nd Global Star Party with the theme of orbits. And we have a great lineup of speakers. We have 3 new presenters that have never been on Global Star Party before, so we're real excited. I am always happy to introduce each and every Global Star Party with David Levy. David is, and all of us here at Explore Scientific are preparing for something called the Arizona Dark Sky Star Party, which will happen in September of this year, the 21st through the, I think it is September 25th. And I am supposed to go out this month to do kind of a survey of the area and check it out and just make sure that everything is in place for this very important star party. It will be a hybrid event, meaning that we're going to do what we normally do for Global Star Party, but with a real star party setting as well. So we're going to have speakers that we normally couldn't get because, you know, flying all the way around the world to go to a star party is not possible for a lot of people. But we're going to bring it on for this very special GSP. I will also tell you that next week's Global Star Party is going to celebrate the birthday of Galileo, which is February 15th. So we're really excited about that as well. But I want to turn this over to I now have this lineup of very, very dear friends, which is awesome, you know, to introduce each time. But they're each and every one of them very special in their own way. They give their all for educational outreach in astronomy. Some of them have been doing it for most of their lives, if not all their lives. So, and one of these people that's near and dear to everybody's heart is David Levy, very special friend, one of my very best friends. And I'm going to turn it over to you, David.
Well, thank you very much, Scott. And it's a pleasure to be here. Pleasure to be here with all my friends and people all around the world who are at this 82nd Star Party. We have some birthdays to celebrate this week. February the 4th was Clyde Tombaugh's 116th, I believe, birthday. Sadly,
That's right.
He's not around to celebrate it with us, but still, that's February the 4th was his birthday. And February the 18th will be the 92nd, I believe, anniversary of the discovery of Pluto, also by Clyde Tombaugh. And so that's kind of interesting. Scott asked me to show this book that I have. And here it is. It's my autobiography. It's called A Night Watchman's Journey. If you're interested in getting it, you can get it if you're living anywhere in the world except the United States. Go to www.RASC, Royal Astronomical Society of Canada.ca, Canada. And in between watching the Canadians get their gold medals, you can get a copy of this book. Also want to mention that like David and Mike, like David and his friend, I'm going to be coming out with a book meant for children. Oh, Adrian has a copy there already. I'm going to be coming out with a book for young readers. It's called Clipper. And the reason it's called Clipper is that it's about a magic beagle. And as John just mentioned, I'm very, very much hoping, if I am. Oh yeah, right. Thanks, Wendy. I'm very, very much hoping that it'll be out in time for the Astronomical League so that people can get it there and get it signed at the Astronomical League meeting this summer in Albuquerque. Anyway, for my quotation of the week, I wanted to quote to you this week from Homer's The Iliad. But depending on what translation I use, it's kind of a different, oh, I forgot to say this. So before I get to the quote, if you live in the United States, and there is the possibility, slim as it may be, that some of you may actually live and may now be in the United States. You can get a copy of the book from Starizona, www.starizona.com. And they are I think the only distributors in the United States that have it. And anyway, back to the quote. Depending on what translator you use, it's a completely different work of art. George Chapman did a beautiful translation. Centuries later, it inspired John Keats's most famous sonnet on first looking into Chapman's Homer. But later on, there was Alexander Pope's translation, and that gives me the quotation for the week. A peaceful guest, he sought Mycenae's towers. Armies, he asked, and armies have been given. Not we denied, but Jove forbade from heaven. While dreadful comets, I don't understand dreadful comets, but let's say it, dreadful comets glaring from afar forewarned the horrors of the Theban war. And so now we'll go away from the dreadful comets to magnificently beautiful comets and give it back to Scott Roberts. Thank you.
Dreadful. What is, can you imagine, can you just imagine living in those days and seeing a comet and not just being filled with awe or something miraculous or something incredible, but being filled with a feeling of impending doom and dread. I don't understand that,
I can certainly understand it these days. Every time I turn on the television set, I have that feeling. Except this week watching the Olympics. I'm really loving the Olympics.
The Olympics are great.
Watching the skating, the downhill skating. I can't believe how steep that hill is, and they don't fall off and down into the valley, never to be seen again. But usually when we turn on a television set, we get the same feeling that the ancient people did when they saw dreadful comets. But nowadays, comets are to be enjoyed, not to be dreaded.
That's right. Yeah, don't dread. Get out your telescope and look, and then maybe take some images, because the images also are just amazing. If you don't have to go very far into social media to see some beautiful stuff.
Maybe we'll be able to see a comet at the star party this fall. I don't know of any bright ones that are going to be around then. But
Maybe you'll
Karim has
discover
his fingers crossed, and Karim's going to be heading a very, very interesting session for children this Sunday on the 13th of February, just before the Super Bowl and during the Olympics. But so Karim's daughter is going to be giving a presentation this Sunday, and we might be able to have it on one of the GSPs in the future. I was supposed to keep that a secret, I think, but I'm sorry about that, Karim. It's all out. Anyway, back to you, Scotty, before I say anything else.
Before you say anything else, huh? Okay. Well, we also have other dear friends and amazing contributors to amateur and as well as inspiration for professional astronomers. David J. Eicher, he is the editor-in-chief of Astronomy magazine, probably the world's most read publication on astronomy. David can give us more details on that, and I wish he would. What is the latest data or stats on how well read the magazine is today?
The circulation of the magazine in print, the people who were old like me still wanted in print, and that's about 100,000. And the visitors, it's called in the business unique visitors who go to a website each month is what gets tracked, and that's about 1.3 million these days per month to the website. And by the way, this is kind of a secret, but not really. There's a very new and fabulously better website that is going to be rolled out soon for our magazine. And which is astronomy.com of all original names, but it works. And then the social media reach is about 1.5 million, with Facebook and with Twitter and with Instagram. So, so it's by far the largest community of astronomy enthusiasts in the world. And it's the largest American publication on the subject by more than a factor of 2. And has
There
been
you
for a long, long time, actually, which not everyone realizes in amateur astronomy, but it's been the case for about 25 years.
Yep. And so it's always exciting to get an issue of Astronomy magazine, and great articles, beautiful illustrations, and extremely informative information about where the planets are going to be, what's up in the sky. It's a great source. Really, if you didn't take anything out observing with you, a copy of Astronomy magazine would do the trick for sure. So we're very fortunate to have that publication. But I think also people are very fortunate to have David Eicher at the helm. And you've been there for a long time, and I know it's a labor of love.
At the end of this year, Scott, I will have been at this magazine for 40 years, believe it or not.
Wow, you're not even 40 years old yet, right?
Well,
How did you do that?
They put me to work when I was, 6, but no, it's been a long time, but I've really enjoyed it.
Yeah. Wow.
Yeah.
That's amazing. Well, maybe one day we can get a tour of Astronomy magazine. So we'll
Absolutely.
We'll see what we can do there.
We're 2 weeks into actually going back into the office on some days now. So we'll open the thing up and do a tour there eventually here. Yeah.
That's right. So today you told me that you're going to show your collection of LEDs, and I joked that we're going to get the lead out, but are some of these LEDs also minerals or classified as a mineral?
Yeah, I'm grouping minerals in so that we don't have to go through all 5,000 of them and drive you crazy. But we're doing some planetary science, looking at some of the popular minerals, and these are all minerals today that have lead as a sort of a primary component of the chemical formulae, and with other elements in there too, most of them. But lead is popular because it produces colorful minerals. Often with the color scheme of what happens, and I'll show some images of them. It's one that you have to be careful with, though, because of course lead is very poisonous to breathe or ingest. So you don't want to have these specimens at your breakfast table playing with them, and throwing them around.
Or under your pillow or something.
No, it's dangerous stuff. You don't want to be grinding up particles and breathing it or eating it, ingesting it. It plays havoc, and you can read about, really amazing historical stories like the Franklin expedition, if you'd like, and what happens when they didn't quite realize that lead would poison you, and it's not a good outcome. But what it does is it actually interferes, it interacts with and interferes with, among other things, with enzymes in your body. And so it has all sorts of nefarious effects on cell structure and composition. And so it's not good. So you want to stay away from lead, be careful with lead, but it produces some beautiful minerals, which I'll talk about and show a little bit here.
Great. And how rare is lead as a mineral?
It's relatively rare. I'll show some native lead, and it's relative, which is primarily just lead atoms. It's relatively rare as a native element because it likes to combine with things, and so it exists as an element in lots and lots of minerals. But native lead samples are pretty unusual.
Okay. Well, we're going to let you take it away.
All right. So I will again see if I can share my screen and see if I can put my PowerPoint on the shared screen. And do you see that now?
Yes.
And I will start the slideshow. And this is not lead, but I've been leading off with another, it's pretty crystal, is tanzanite, which is a complicated silicate mineral and a beautiful to cut in lots of jewelry and so on. Since the 60s, it mostly comes from Tanzania, the great specimens of it. But I will talk, of course, about how the universe is a universe of order, A great hero of mine and of some of us here, Thomas Jefferson, used to say, "I believe in a divinely ordered universe." Even beforehand, Isaac Newton said, "Truth is ever to be found in the simplicity and not in the multiplicity and confusion of things." Well, the universe is ordered not by supernatural design, but by the principles of physics and of chemistry. Minerals demonstrate that in that atoms are assembled in not randomly or by magic, but in precise ways because of their electrochemical attractions. And that's what creates these crystals and these minerals and the stuff that makes up planets. It guides them into what mineralogists call a specific crystal lattice that allows the material to come together and form these substances in the right way. So lead minerals, as we said, stay away from eating them. It's a native element. The symbol is Pb. It's a soft and poisonous metal. Native lead is pretty rare. It's most often found in galena, which it forms with a lot, which is lead sulfide. Lead and sulfur like to link up a lot and form this mineral galena. Color is gray, but it's often coated white with other minerals like a hydrocerussite. It was named originally by Pliny the Elder, a plumba nigrum, black pencil, but named as a chemical element and not a mineral. Native lead was discovered in the early 19th century in Sweden. It's a member, as gold and silver are, of the copper group. Romans renamed the soft metal plumbum and used it for water pipes. Again, not a good idea, but they didn't know. Unfortunately, we still have some lead pipes, as we know, plaguing us in this modern world, which is a terrible, awful, shameful situation and is still harming people because they're ingesting some lead without really having to. So this is a problem we need to clean up by this point. We're supposed to be having a civilization here, as Jerry Seinfeld used to say, you know.
Right.
So we'll hope we can get this taken care of. In the meantime, it is interesting to study. It's also, like gold and silver, cubic in its crystallization. A fancy word is isometric. And you can see the basic crystal structure here is just a cube. And now we can just look at some examples of lead minerals, which you have to be careful with, but not as careful, say, as you do with radioactive minerals, of course, but which we'll get to eventually here. But lead is you know, you simply don't want to ingest or breathe it if it's ground up or if it's near food. It's big trouble, of course. This is native lead with an associated mineral called tremolite from the type locality in Sweden here, Dalarna. And so you can see it just looks like a sort of a silvery metal here. In native form. This is an example of the really common stuff, the way lead likes to form with sulfur and produce these galena crystals. These are these interesting sort of warped hexagons here are a crystallization that's called twinning of crystals that happens when crystals repeat in a pattern. It's called Spinel law twinning here, and this is an example of it from Bulgaria. And again, it's sort of this silvery, you know, looking metallic sheen. However, lead forms with lots and lots of other things, and there's some more complicated and more attractive, colorful minerals that it produces. One of them is pyromorphite, which is lead chlorophosphate. This is from a very famous mine in the West, Kellogg, Idaho, called the Bunker Hill Mine. That's a very famous mine for collectors of this lead mineral. Here's another example of pyromorphite, and you can see the very different colors and crystal shapes you can get from the same mineral here, but these are sort of long barrel-shaped crystals from Bulgaria with a sort of a chocolate color to them. Here's another lead mineral that's very popular because it comes in all sorts of bright colors for collectors, called mimetite, lead chloroarsenate. So there's, you know, just to make it even safer, there's a little arsenic in there in this one. This is from the Black Forest in Germany. That's a very old and popular site for this kind of mineral. This is quite a rare mineral, this sort of electric sky blue mineral called leadhillite. lead carbonate sulfate hydroxide with a little white cerussite as well. And this is from a very famous mine that's now closed called the Mammoth St. Anthony mine in Arizona. That's quite a rare mineral here. And this is a piece that's about 3 inches high here. Well, here's more mimetite, and you can see, you know, lead often gives you this sort of red and orange and yellow, very, you know, showy mineral specimens. This is one from a relatively recent find in Iran, and they're old minerals that have come out of mines for hundreds of years or dozens of years, at least in the American West, many of them. And then there are also minerals that have been around for a long time, of course, but they've only come out into the sort of Western market pretty recently. And this is the case with these Iranian specimens here, the last 10 or 20 years here. This is cerussite, and it shows a sort of what mineralogists call acicular or needle-like crystals here. It's lead carbonate, and from another very famous Arizona mine called the Flux Mine in the Patagonia Mountains here. Here's mimetite again, and again you get sort of these very orange, yellow, very bright crystals that are barrel-shaped here, hexagonal. And this is from a famous locality in Thailand that's also been sort of producing specimens out into the market for the last generation or so. Here's another mimetite. This is from a very famous older mine that the Germans went down long ago and started mining in Namibia called Sumeb. That is a huge, very famous area for producing all sorts of important minerals for the last couple of hundred years. Here's another very bright yellow. There's an example of mimetite that comes from San Pedro Corralitos, Mexico. That's a very famous region of lead and other minerals here as well. And here's an old specimen. This is an area that was sort of mined out a long time ago. This is pyromorphite, back to the lead chlorophosphate. That should be phosphate. That's an autocorrect there, I think, trying to screw me up. And this is an old area of mining in Chester County, Pennsylvania. So this specimen was probably mined, 150 years ago or so, an oldie. Here's another interesting lead mineral called linerite. Now this is lead copper sulfate hydroxide, and there's a very famous area, the Blanchard Mine and others in Bingham, New Mexico, very dry, arid region, and it produces this so-called famous Bingham blue of a couple of different minerals, both linerite here and also fluorite that it produces in very vivid blue colors. Here is an old-time German, fairly large piece, about the size of your head here, pyromorphite crystals. And again, just showing the kind of range of color that you can get from little impurities that push things toward being brown or yellow or red or green or blue.
I see. Is does it also have to do with pressure and temperature and stuff? That
it does, and you're right, exactly right, Scott. So minerals crystallize over differing periods of time and with differing pressures and with differing temperatures. And all of those affect the crystal habit or shape or structure, as it's called. Mineralogists call it the crystal habit. And also the coloration is usually from impurities. Sometimes it can be from radioactivity or other aspects as well, but usually it's from a small number of atoms that sneak in there, and they're neither lead nor chlorine nor phosphorus here, but another little, and I didn't prepare what the contaminants were with each of these pictures, which I probably could have, but some of the coloring atoms that change the colors of different minerals are not known well yet. It's kind of like, what are the parent bodies of different meteorites? Well, we don't know in most cases because of running the puzzle backwards. And it's very difficult in some cases to know exactly what the coloration of minerals is caused by. That this is an area that's fairly young in its scientific analysis. Here's another lead mineral. This is a fairly simple one, lead sulfate, and this is called anglesite, and it produces these usually translucent or transparent white or transparent crystals. Here, this is from an important Moroccan mineral region that just shows you the great range of what lead can do in different specimens here. And here's another mimetite, and this is again going back to the Black Forest in Germany, which is a good lead mining region, and it shows you these little tiny rosettes that can form as well with various shades of yellow and orange and red. So that's kind of a quick showcase of the kind of range of different lead minerals. And again, David has his kids' book coming out, and I didn't want David to be alone. So Michael Bakich, my pal, and I also wrote a kid's book, which is coming out in the fall, in September. And it's a children's introduction to space exploration, which is a very exciting thing for all of us these days. And you don't have to just be a billionaire. We will show that in the future here to go to space. So this one's coming out, and we hope it will be a nice pairing along with David's book as well.
That's great.
I have a comment I'd like to make, if I may.
Yes, sir.
It'd be interesting if one week you could tell us a little bit about what got you interested in meteorology. My interest comes from taking geology at Acadia University. But while we're at it, this is not a lead mineral I'm going to show you.
Yeah.
This is trinitite.
Ah, yes.
Trinitite was formed on only one day. It was formed on July the something. I think it's July the 6th. Or no,
6th.
July
6th. Yep.
the 6th, 1945.
Yep.
During the first atomic test in New Mexico.
Yes.
And that site is now a National Historic Monument.
Yep.
And it's open twice a year. And Wendy and I and a friend went there a few years ago, just before the pandemic started. And we were able to see it. We were able to go right up to the thing. And it turns out that our son-in-law's father, I guess, has a collection of trinitite, and it's all encased in lucite. And still a little bit nervous getting close to it, but I think it's okay to show the picture of it. But anyway, that's trinitite.
Showing the picture of it is perfectly fine. And you know that most all, mineral, and I'll show some radioactives someday, but David, you've set me up perfectly, and I'll try not to drag this out, but to very quickly talk about how I got into mineralogy and
please do. I really would like to know.
And so on. I've got some trinitite in the basement, and just very quickly, it's fairly weakly radioactive, but there are some minerals that are very hot, if you will, radioactively. But if you get at a distance of about 20 to 30 feet from radioactive minerals, the inverse square law means that you're essentially dropped down to the background radiation, so that's a fairly safe distance from most all radioactive minerals. You wouldn't want to carry those around in your pocket for 6 months, certainly, but if you're that far away from most radioactives, you're generally safe again. You tied in the story perfectly, David, of how I got interested in this stuff, because it was through my father, John, who, when I was young, he was a professor of chemistry and organic chemistry, and
not surprised to hear that.
And he infected me with all of this stuff, taking me around on long summer trips when I was a child to Western mining sites and Western history and Civil War sites and American history and astronomy, and got me interested in all this stuff. And who cares about that kind of stuff, when you're a young teenager? Well, it comes back, you're infected with it later if you were exposed to all that stuff. So he got me into it. And he actually, I think, as you know, David, was one of the Manhattan Project scientists in New York at Columbia with Harold Urey, who invented the atomic bomb. And it wasn't Trinity bomb, the plutonium bomb, which had to be tested. What my father worked on in New York was the uranium bomb, which was a simple triggering device, a gun bomb. So they knew that would work and they didn't have to test it. That was the first bomb that was made, actually. And the plutonium bomb was what had to be tested, which became the first one to be detonated, even though it was the more complicated bomb to make, and it was made last. You know what I mean? So anyway, it was none other than a Trinitite related producer of science who got me into all this stuff to begin with by taking me around to all these sites. And he also gave me his collection of minerals, which were mostly, when he was self-collecting out in the West in the, believe it or not, as early as 1926, but up until the time when he worked on the Manhattan Project during World War II, you could collect stuff at the mines then. Well, you can't do that anymore. They're all closed. So I became a collector going to things like the Tucson Gem Show, which is going on now, which is the way you have to collect things now.
Well,
But once infected with this curiosity, be careful for science, because it's hard to get rid of, as you guys know, once you're really into this stuff.
Right. So David, do you have like a room that's just devoted to your collection of minerals?
I have, some of, the problem with books and with minerals and with documents and with other things is that, watch out, they multiply, So I have the core of my collection in lighted cases in our house, which is kind of the best of the best stuff. And I thought, I'm not going to do, well, of course it happens this way. So I have a lot of stuff that's boxed up as well, because I have about 3,000 specimens altogether, and about a little less than half of those are on display right now.
I see.
Yeah.
A little less than half. That's still impressive.
Yeah.
That is impressive.
Dave, I have a question for you.
Yes, sir.
In one of my previous lives, I worked quite a bit with lead glass. And lead glass is heavy, really dense. Now, look at the minerals that you've had on display here. When you pick these things up, you get the sense of denseness, don't you?
Absolutely right, John. Yes, you can. The heft with these specimens is impressive. You can feel that this is not ordinary rock stuff. They're really dense and heavy for the size that they are. So you can appreciate that there's lead in this piece. Exactly right. Yeah, the very same thing with your leaded glass. Exactly.
Okay, thank you.
Yeah.
One of our people in chat or this joke, and he says, David must be a beginner. That's very cool.
I'm a beginner at everything, but I keep working on everything, and eventually maybe I'll be slightly beyond a beginner. For 40 years, I've been a beginner. Yeah.
Awesome. Well, to have the beginner's mind is very important and very Zen-like, so.
Oh, and Scott, I promised you, I wore this shirt last week. I promised you asked about this meteorite bracelet that a friend gave me. So I promised. So this is Brian May's guitar shirt here that he gave to me.
Wow.
And this is can you see this? This is scotoline and gold. And you may be able to see
beautiful
that there's a BM engraving in there. And that's Brian's bracelet, which he said, I have enough gold meteorite bracelets. Dave, you take this.
Enough.
So I said, okay, if you insist, So this
Can
is.
you ever have enough gold meteorite bracelets? I don't know.
This is quite heavy as well, but there's a lot of gold and a lot of scotoline in that one.
Well, that's very cool. That is very, very cool. Well, Brian May, thank you for helping us to share this kind of stuff. That's awesome. Thank you.
Thanks,
David,
Scott.
great presentation. Now, next Global Star Party, you're going to be at your own star party, right? For Astronomy Magazine.
At Astronomy Magazine Star Party next week in, of all places, David, Tucson, Arizona, at Pima Community College, the Eastern Campus.
No kidding.
If you can come to that, anyone who's in the region of Tucson, Saturday night, 6:30, Tucson, Pima Community College, East Campus. There are a lot of people who are going to be the TAAA, the Tucson Amateur Astronomy Association, will be there. Michael Bakich and Holly Bakich will be there. Ray Shabinsky and his wife will be there. Jim Knoll of the TAAA and club members will be there with a lot of telescopes. And the observatory there at the college will have their telescope open as well. So we'll be looking at all sorts of stuff in the sky before we sneak off to the Tucson Gem Show as well.
Well, I think I need to put the kibosh on that for Wendy and me right now, because we are still being very, very careful with COVID. It's not quite over yet. It's getting better, but it's not over yet. So I will be there at your star party in spirit.
I will see you the next time I get to Tucson after this then, David.
Okay, thanks.
Okay, all right. So our next speaker is John Goss from the Astronomical League. John has given many, many presentations. He will be, I think, are you the featured speaker for the next Astronomical League Live? Is that right, John?
That's the rumor. Yes. No, actually, yes, I am. And I do have something prepared, at least halfway prepared right now. And that'd be the end of next week. So yeah, tune in for that.
Excellent.
Oh, and I'll try to make it as controversial as possible.
So, of course.
Controversy in there.
Absolutely. That's right. That makes it always exciting. John, you are former president 2 terms, 1 term? 3 terms? How many times? Twice. Wow. Okay.
Twice.
Yeah. So a great, stalwart of astronomy, of the Astronomical League. Every time you guys come on, I do like to talk about the Astronomical League and what you guys do. It is the world's largest federation of astronomy clubs. Over 300 member clubs are part of the Astronomical League Federation. They have over 20,000 members, and they have members all over the world. If you're not able to join an astronomy club that is an Astronomical League club, which would make you an automatic member, you can join the Astronomical League as an at-large member from anywhere. And so you only have, here, I'll put the website in. It is astroleague.org. And you can join up today and be part of this huge organization. The Astronomical League also is well known for its award programs. It is extremely well known for its observing programs. So you can, whatever level that you want to go to in astronomy, the league is there to support you, to teach you, and to inform you, especially with their Reflector magazine that members all get. So anyways, the league comes here on Global Star Party every time. They rotate the officers of the league, and they present questions that members can answer. So if you've never tried this before, you're going to want to try to answer some of the questions. You then get thrown into a pool of people that they pick winners from. So for all the people that answered those questions correctly. So I'm going to turn it over to you. Thanks.
Oh, well, thank you, Scott. You said quite a bit there, so I don't have much more to add to what you said.
Well, you can talk about the next Alcon. Okay.
Yeah. Okay. Well, there's another thing I'd like to bring up. It's something that you were kind of alluding to about everything that the Astronomical League is into. The league is 75 years old, and it has grown. Obviously, it has grown in its scope as far as members and what it does, but it's also been it remains technologically relevant. As time goes on, we try to change the times. Right now, the big emphasis is on imaging. So a lot of our efforts are looking to recognize imaging and trying to get people out there with telescope and some type of camera at least, and see what they can do. So the league isn't really a stagnant organization. This summer, we're having an Alcon. Every year we have Alcon, which is the Astronomical Convention, national convention, someplace in the United States. 2 years ago, well, will be 2 years ago for the first time, we didn't have an Alcon for obvious reasons. This past summer, though, we did. It was a virtual meeting for 3 days. And I'll have to say, I was not an organizer of that, but so I can look back and I can criticize it, but I have to say it was pretty interesting. There was a lot going on, and it held people's attention from beginning to end, and I was really pleased with it, and I think with the officers sure were. So this year we want to have we will have an Alcon in Albuquerque. We'll have to see how much of a hybrid event this is going to be. Will it be all in person or some of it virtual? I kind of think there's going to be some virtual stuff always in these conventions now. You know, times are changing. People have gotten used to this, and they'd like to see some of this stuff. But anyway, and enough of that. What I'm here for is to go over some questions that was asked last week, and offer 3 more questions for this week. So let's go ahead and get started with that.
Okay.
Maybe. Okay. Oops. Sorry. Okay, we'd like to start off by just emphasizing the hazards of solar observing. If it's done correctly, there are no hazards, but you always have to be careful in what you're doing, because the sun is, 400,000 times brighter than the full moon. So it's just not a little bit brighter than the moon. It's a whole lot brighter than the moon, and you never want to look at it without the proper filtration and filter devices. So make sure you know what you're doing. But if you have the correct filters, that'll do that, and you have your finder scopes all sealed off and all that. You know, the sun gives a very rewarding view, and there's always something going on, especially now since we're headed towards solar maximum in another 3 years or so. But anyway, so always be careful when you're looking at the sun. Question number one, where'd it go? Question number 1 from last week. Who is the founder of the Greenwich Observatory in England? Very famous guy, because he has a star catalog named after him, John Flamsteed. And places like this, if you're ever an astro tourist, go to places like this. It's always extremely interesting to see how it is or how it was back then. Question number 2. Which planet in our solar system has a year that lasts approximately 84 Earth years? So for me, I'd only be 9 months old now. So if I was on this planet, well, Uranus. Everyone's favorite planet, Uranus. Question number 3, another planetary question. What is the fastest rotating planet in our solar system? Well, Jupiter is pretty fast. What's it, like 10 hours? Something for it to go around? Maybe it's a little bit less than that. But its speed causes it to flatten out, and it's throughout its atmosphere, so it's not really round. It's a kind of a fat oval. Interesting to look at through a telescope, small telescope. So answers from last week, we had a number of correct answers, and these people's names will be added to the door prize list. Cameron Gillis, Paul and Kathy Anderson, Rich Wakeling, Josh Kovac, Rich Eubank, Billy Beckett, Don Knabb, Andrew Corkill, and Neil Cox. So thank you for sending in your answers. Now let's go on to this week, see what we got. Okay, question number 1. This planet shines at its brightest 4 weeks before and after it reaches inferior conjunction. It reached inferior conjunction on January 9th. Tomorrow morning, February 9th, it again attains its brightest. This planet is A, Venus, B, Mars, C, Jupiter. This question is really designed for you to start thinking of what's in the sky, what you can see, what you can go out and find. This would be pretty easy to do tomorrow morning if it's clear. I think it'll be where I am. I don't know. Question number 2. Tomorrow night, excuse me, one moment. Tomorrow night, their near first quarter moon passes in front of the 4th magnitude star Capitari. This can be seen by observers north of San Antonio, Texas. For most of the country, people can see this, and it's a binocular event. So go outside and take binoculars with you. This type of event is called A, an occultation, B, an eclipse, C, a transit. So that would be tomorrow evening. Oops. Sorry, it's not responding. Question number 3. This is a tough one. The value of the moon's gravitational pull on an observer depends on how far that person is from the moon, following the inverse square law. That's something we've all learned back in college in physics. The further from the moon, the less the pull. Makes sense. An observer on Earth experiences about how much more pull when the moon is nearly overhead than when it lies on the opposite side of Earth. Okay. A, about 0.5%. B, minus 0.5%. C, 6 to 7%, depending on where the moon lies from its apogee or perigee point. All right, so on those questions, be sure to write them down, correct answers, and send them to secretary@astroleague.org. Next Friday night, this is a little ad for some clown there is going to be talking about astronomy, but I have a presentation called All Is Changed, which is a little bit more of what I was just saying about how the Astronomical League has modified itself over the years and how things are changing for us all. Okay, and on that note, I'll turn things back over to you, Scott.
Okay. All right. That's great.
Stop share there, John. Okay, buddy.
Okay. All right. Well, thank you very much. Up next is Professor Karim Jaffer, and Karim is from John Abbott College. He is an outreach ambassador extraordinaire for the Royal Astronomical Society of Canada, the Montreal Center. And I would class him now as someone that's very instrumental in global outreach. He is making use of all the tools and all the venues possible and inviting, I mean, the guy just like mixes it up and invites people and gets people involved, to take advantage of the way that we're able to interact with the world today, especially our world of astronomy. And Karim invited me on Monday to be part of a program that is a podcast. I mean, they had like 250,000 live listeners, something like that. So I was very, very impressed with that. How do people find that program, Karim?
So it's on astroradio.earth. It's a volunteer radio station based out of the UK, but broadcast globally. And if you actually just go to the website, astroradio.earth, you'll see the link to listen live. And they have programming throughout the week, but the Reach Out and Touch Space panel show that I'm on records every Monday and then replays a couple of times during the week. So awesome. Thanks, Scott. And I have to say, I saw the topic for today, orbits, and I thought for a second there that Scott's kind of looking over my shoulder because that's what I talked about today in class. So I'm going to take some time to go through orbits and talk to you a little bit, but I'm not going to take the hour and a half that I do with my students. I'm going to kind of boil it down as best as I can into about 10, 12 minutes of digestible material. But I do want to thank Scott for coming on to our awesome show yesterday. It's available currently on Mixcloud, and you actually have a link on Explore Scientific. I have a link on my webpage. We have a link on the Astro Earth Cafe on Facebook. It was an amazing show, and we had such a good time talking to Scott. I was just on our forum a few minutes before we started tonight, and the panel is still abuzz because Scott talks all about his passion for outreach, the story that brought him to the point where he's at with Explore Scientific and with Explore Alliance. And it's just a wonderful discussion with people who have a similar view to why it's important to share what we get to see with the night sky. So speaking of sharing what we get to see, I wanted to do a quick check-in with the Montreal Center and tell you that we have our next Citizen Science series coming up next Wednesday on February 16th during our regular clubhouse time, 8 o'clock. We're going to be discussing a small bit on quantum entanglement, and then we're going to be diving into some of our members' observations of double stars, including the double star program that we do at our own center. And then later on this spring, we're going to have a speaker talk about the double star program from the RASC National. So we're going to get to share a lot about double stars. It's an area of emphasis for us in the Montreal Center. And David is actually one of our certificate holders for the double star program. And it's a challenging program. So if you're interested, please do join us next Wednesday during our clubhouse for the Citizen Science series. I also want to mention what David was talking about earlier, which is we have been working with the Denver Astronomical Society on setting up an international club for youth. And the club now has taken shape. They're calling themselves the Cosmic Generation. And their inaugural event is this Sunday at 2 p.m. Mountain Time, which is 4 p.m. Eastern Time for us. And it's my daughter who's actually going to be doing the workshop on drawing aliens and the idea of what are extremophiles and what do aliens look like and how close are the aliens that we have in pop culture to the aliens that we actually see. My daughter was a little upset that I chose this particular picture, but it was the last time that I got a picture of her drawing one of her aliens. So I wanted to use it in the poster. And since David mentioned birthdays, it's her birthday tomorrow. So an early happy birthday to my daughter. And I hope if you know a youth between ages 10 to 17, interested in astronomy, interested in space, loves looking up, loves drawing, or just has an imagination that you want to foster, please do recommend to them to join this event. And after the event, there's going to be a discussion of possible future projects for the kids that are taking part in this international club. We're really lucky that Scott has sponsored the club, and he's actually providing a door prize as well of $150. So thank you, Scott. We really appreciate that.
Thank you.
Nathan, who's one of the executive, is going to be speaking later on tonight in today's GSP. And so I'm going to leave it to him to talk a little bit more about the club itself. What I wanted to talk to you about today was a little bit about our evolution in trying to understand orbits. And when we think back to ancient astronomy or to the indigenous peoples of our different countries, one of the things we recognize is that early on, they saw that there was this set of stars, of bright points in the sky that seemed to move in a relatively predictable pattern, something that we refer to as the celestial sphere. And you have the constellations, which have stories that connect the timing of when those bodies of, when those asterisms or those shapes that appeared to them match what's happening in nature. And they also recognized at that time that there were these other objects that seemed to wander along the same line that the sun and the moon seemed to appear on. And those wanderers, those planetes, as the Greeks called them, were our first understanding that there were other objects that were closer to us than these distant stars. Now, the ancients thought these stars were stuck on a sphere that surrounded Earth, and that because we didn't really feel motion on Earth, therefore Earth must be stationary and everything else must move around Earth. So when they followed these wanderers, they tried to match the pattern of what they saw for their behavior, how fast they appeared, what order they appeared in. And over decades and centuries of observations, they came up with a model with the Earth at the center and these different astronomical bodies occupying orbits around Earth with the celestial sphere at the furthest point. So you had the moon closest to the Earth, followed by Mercury and Venus. And then you had the sun, which clearly had some sort of a different relationship with Mercury and Venus than it did with the other planets, which is why the Mercury and Venus wanderers came closer to the Earth than the sun. And then you had Mars, Jupiter, and Saturn, which were the other visible objects for us. But as they tried to understand this and picture this model, observations came out that were clearly not consistent with the geocentric model. And one of those observations was the retrograde motion of Mars, where we know that at some points in its path in our night sky, it actually reverts backwards in direction compared to how it normally goes. This is something that the Algonquin people in the Cree would call the moose spirit, because when a moose is frightened, kind of runs in a circle to see what's frightened it. And if nothing frightened it that it has to be worried about, then it keeps going on its path. So this was something observed by all the ancient peoples. And they tried to find a way to adjust their model of an understanding of the world around them, the universe around them, to match this retrograde motion. And so what they did is they introduced this idea of epicycles, where the planets, these wanderers, weren't just moving in a circle around Earth, but circles upon circles, with the idea being that if you had these epicycles on the orbits, because of the relative motion of these two circular orbits, you would see retrograde motion occur at different moments in time. Now, unfortunately, it's not a precise centering of the circles upon circles. And so you have to actually move them off center. And so you have a deferent, you have the equant, which moves the cycle. And it just became incredibly complicated. And when we try to picture this geocentric picture, all of a sudden, these objects moving around the Earth start to attain these incredibly complicated circular inside of circular patterns. And you realize that this really isn't the simple universe that we were striving to understand. And so the other models started to become popularized, which had been brought up by the Greeks and the Arabs. And then Copernicus brought it up again, which is the heliocentric model, this idea that you have the sun in the center and all of the other planets around the sun. And the heliocentric model would have been fantastic, because one of the things the heliocentric model immediately does is it explains retrograde motion. Because if a planet is further out than Earth, like Mars is, if it's moving at a slightly slower pace, which is one of the ideas that Copernicus and others put forward, and we now know mathematically fits, you end up with this crossback of the motion of Mars in our night sky and our view of it compared to the celestial sphere behind it. So retrograde motion came in naturally in this type of a heliocentric system. But when you tried to predict the positions of planets using this heliocentric system, it was just as bad as the geocentric system in trying to predict where the planets would be the next year, 5 years later, 10 years later. So there was something missing from the picture. And we've heard previously in other GSPs about Tycho Brahe and the amazing observational work that he did. And he was hoping with his observational work over 20 years, as well as the reams of data that he had compiled from ancient observations, that it would be possible for somebody with a better mathematical bend to find a model that fit, hopefully the geocentric, and if not the geocentric, at least find an understanding of this. And Kepler came along and was able to do so by determining that the heliocentric model works as long as they're not perfect circles, but they have a little bit of eccentricity, a little bit of an elliptical orbit. Now, I will point out that whenever you look in books, whenever you look online at diagrams of Kepler's orbits, the ellipse is incredibly magnified. It's not that much of an ellipse for any of the planets within our solar system. It's not that much of an ellipse for most orbits, but you can take advantage of the ellipse when you set up orbits of satellites. And we do that with the Juno probe around Jupiter, as well as the Molniya satellites here on Earth. But what Kepler's laws were the idea that there were three fundamental rules of these elliptical orbits. The first is, one of the focuses is the sun. The other focus we don't worry about. But one of the focuses is the location of the sun, and the orbit is actually a center of mass orbit. Most objects orbiting around the sun, the center of mass between the two masses is within the sun, so you don't see the sun really wobble. The second was really ingenious. It was this idea that at every interval of time, the same area has to be swept out by the object orbiting. What that means, in very simple terms, is when you're closer to the object that you're orbiting, you move faster. When you're further away, you move slower. And we make use of that in a lot of communication satellites that we set up for the northern and the southern polar regions. We also make use of that often in terms of understanding the reason why the motion of the planets in our night sky is slightly different for us in January versus in June, because in January we are closer to the sun, so we're actually moving a little bit faster in our orbit. And then the third one was this incredible mathematical fit, but it didn't explain why this was the case. But the mathematical fit was this idea that your distance from the sun and the amount of time it takes you to complete your orbit have a beautiful relationship. The time it takes you squared equals the distance you are along the major axis cubed. And that was a very straightforward relationship that seemed to fit for all planets in our solar system. And in fact, next week, my students are going to use an observations of the moons of Jupiter to figure out the mass of Jupiter using this observation that Kepler made. Now, Newton came along and explained a little bit more of where all of this came from, and Einstein has advanced this with an explanation of gravitation. We're not going to go into all of that. What I want to talk to you about is what this means to us for what we see when we look up at the night sky. So this is our sky tonight. This is where all the planets are when you go out and look tonight, right now. And what you see is, first off, we're at the first quarter moon. The moon, the earth, and the sun make this nice right angle. So if you go outside, you get to see the first quarter moon. You can even zoom in and see that phase beautifully, see some of the features, see the mares, and really kind of pick out the details of that moon. Now, if you look on the opposite side from the earth through the sun, you see Saturn blocked by the sun. So Saturn is in conjunction with the sun. So we can't see the planet Saturn in the evening or in the morning at the moment. Jupiter is incredibly close to sunset. Mercury, Venus, and Mars are on the other side. So they're in the sky before sunrise. And that's actually what we see. If we go out right now and we use stellarium to try to figure out what's visible, Uranus is the only planet that would be visible for us now. Jupiter has set and is really close to the sun. Saturn is blocked by the sun. And in the early morning hours before sunrise, you will see Mercury, Venus, and Mars. Now, one of the impetus that I had for putting this together was actually John Goss put for a really nice handout for the Astronomical League, talking about the orbit of Mars versus the orbit of Earth. And specifically, what he was pointing out was, because Mars orbits about twice or once every time the Earth orbits twice, we catch up to Mars every couple of years in opposition. So our opposition of Mars, when the Earth, Mars, and the sun line up, and we can see Mars throughout the night sky, that happens about every 2 years plus a little bit. So in 2016, 2014, 2018, and last year, 2020, was one of the best because we actually had Mars at its largest angular size in our view. This year, on December 8th, 2022, we will again be in opposition with Mars, and then the following time will be 2025 January, just more than 2 years later. This closeness happens because we're all orbiting around the sun counterclockwise. And because Mars is further out, it's orbiting slower. So the Earth laps it a couple of times. And that's where the retrograde motion comes in when we see each other close to opposition. But what's really neat is we use this in order to plan the most efficient way for us to actually explore Mars. So we set up our missions in order to go to Mars when it costs us the least amount in fuel to get there. So when Mars is closest, which is opposition. So in 2016, the first part of ExoMars, the orbiter and the lander went, and unfortunately the lander wasn't able to survive, but the orbiter is there. And this year in 2022 in September, ExoMars lander with the rover itself is going to hopefully launch from Russia and is going to go to Mars and enter Mars in early 2023 so that it has the least distance to travel to get there. And we know that this works really well because we use that for Mars 2020 for sending the Perseverance rover. So the understanding of the orbits allows us to really safely and efficiently explore the solar system. So to end, I'll actually invite you to join us in a couple of weeks on Saturday, February 19th, to celebrate 1 year since Percy landed on the surface of Mars. learn a little bit about the goals of the mission, what we found so far, and what comes next. And I hope you enjoyed this little excursion into what we now understand about orbits and what it means to us in terms of solar exploration. Scott, back to you.
Thank you very much. That was a whirlwind of epicycles and orbits, and I think people are going to have to watch that a few times to get all of it and digest it. But that's very cool.
An hour and a half would have been better, but I figured, let's just touch on a few highlights there. I think David had something he wanted to say about the ancient astronomy.
Yeah, I didn't really want to talk about the epicycles or the ancient astronomers, but I did want to congratulate you on a wonderful, with a capital W and a capital L presentation. Clear to everyone to understand. I'm sure that even the children watching us tonight understood it. Karim, you were absolutely wonderful.
Thank you so much, David.
You're a gifted educator, that's for sure. Karim, thank you so much for doing that.
Well, I mean, it came in my wheelhouse. I just finished chatting with my students about it all day. So I figured, let's just bring it in here.
Let's do it. Let's bring it on. That's great. That's great. Okay, so our next speaker will be Adrian Bradley. Adrian inspires us with his amazing nightscape photography, one of David Levy's favorite night sky photographers. Adrian lives in the Upper Peninsula of Michigan, and
no, it's actually Lower Peninsula. But
is it Lower Peninsula? Okay, all right. You're always talking about the UP, but
yeah, because if I go there, I definitely do. But actually, I need to launch my presentation layer self, so that won't take long. I'm launching it right now. And what we'll do is I'll talk on this screen. This is my screen that works. And then you're hearing me come in now. I'm going to join. I'm just going to continue, and I'm going to share my screen from I'm actually in the middle of doing something, so I'll just show you what I'm trying to do.
I am running into a technical problem here. Let me see if I can fix this.
Okay.
Let me see.
So I just added a you want me to go ahead and share my screen, Scott?
Yeah, why don't you do that?
So this is the screen I'm going to share.
And while you're doing that, that's a great picture of the eclipse right behind you.
Thank you. So this is me trying to reproduce a realistic picture, and it's got a lot of work to do because I've got glow here. This image plays into what I wanted to talk about with orbits as how they relate to nightscapes, because you can actually learn a lot about how watching planets over the a couple of years of imaging, say, the Milky Way, which is also the core of the Milky Way, which is where the planets Jupiter and Saturn are near, and you can watch them in motion as you image these things. This happens to be an image where I had this crescent moon, and this is what it looked like as it was setting. And I'm working on cleaning up this area with the healing tool in Lightroom. It's going to take a while to get it just the way I want it. But the idea was we had a moon in the sky, and I was yet able to get some Milky Way detail at this park. Here you have Jupiter in front of the, or in front, if you're going from left to right, Jupiter's over here, core of the Milky Way is there. And it's possible to image the Milky Way even when there's a light source, a reasonably bright light source in the sky, such as the moon. Most of the time when it's imaged, it's dark, and what you see is you generally see just the Milky Way. And here are some other images And I will go to some of these to illustrate the difference over the years as we watch. Jupiter is now here and Saturn is here. I have images where Jupiter is where you saw it in that other photo and Saturn goes here. And you can see where, as we continue to image the core, they move. This was as they were getting closer together for 2020, the Great Conjunction. They began drifting in their orbits to a point where Jupiter and Saturn would become closer together. This was an image taken a little bit before that, but that was 2020. And this past year, if you went to Okie-Tex, or you took any image of the Milky Way, you notice that Jupiter, the retrograde motion, so to speak, that Professor Karim just mentioned, you kind of saw it in action over the last couple of years. Now this is Jupiter and this is Saturn. So in imaging, sometimes it's not about just the pretty pictures that we take, it's about capturing what's going on in the sky. The sky is ever changing and it's ever moving. And one thing that I've discovered just through doing my own imaging is we're capturing a point in time. With photography, we capture a point in time, and we're doing the same thing with the night sky, and it's not stagnant. It's, though we may not see changes over our lifetime to this part of the Milky Way, we do see changes to our own solar system as it appears to us. And that can make it a little more exciting than just trying to create a pretty picture. For me, it's a lot more than that. This is the original, where I'm trying to, the moon, when I took this single image, the moon kind of did this sort of thing where it was in half, but it's a waxing crescent, which we've gotten beyond that point. Really quickly, for those that celebrate Valentine's Day, this is a part of the Milky Way as well. Every once in a while, I attempt my hand at classic astrophotography, where we have the double cluster, the Heart Nebula, the Fish Head Nebula, which is just above the heart in this photo, and the Soul Nebula, and all of the star clusters that are part of it. There are countless objects here, and a lot of times with an image like this, these two nebula will be separated. Maybe they'll leave the double cluster in, and a lot of these stars will be stripped or minimized. But this just gives you an idea. This little section of the Milky Way contains that many stars, all of them, of course, orbiting that galactic center, but we don't see any different part of this galactic center in our lifetimes, because to orbit the galactic center, it takes more years than I can count. One other thing I wanted to do in this quick little presentation is highlight the fact that the galactic core, while it is beautiful, and I'll just throw it up here. So while the galactic core is indeed beautiful, and a lot of photographers will throw this against an impressive foreground, something along the lines of, a river, a waterfall, a large building, a rock formation, lots of things that night photographers will put this Milky Way up against. There are other areas of the Milky Way that we ought to be paying attention to. And going in order, the Lacerta Cygnus region, here's Cygnus, and the Lacerta region, there are some dust lanes here that you can look for when imaging. And this is, as the Milky Way moves along, and the core recedes to the south, there are other treasures in the Milky Way that, if imaged, can be quite beautiful. This is more of the as you lose the galactic center, you have Altair and Tarzed here, and my favorite thing to try and capture, the coat hanger sitting in this region where Sagittarius is now gone, Scorpion is now gone, Ophiuchus, and here you have Vega as part of Lyra the Harp. Tarzed, of course, is a part of Altair and Tarzed. Altair and Tarzed, part of Aquila the Eagle, and Crux is above and not pictured in this particular shot. And then you come down to, as the Northern Cross or Cygnus sets, now you have this region within Lacerta with its nebulosity. And here you have Andromeda. And unfortunately, in this image, I didn't image high enough to show the double cluster region of the Milky Way that I had.
Yeah, but you would have missed all that foreground, you know, so that, that composition is very nice.
Yes, thank you. And then so you have to make some choices in composition when you're marrying it to a foreground. And there was aurora. It was faint. It was on the horizon. I thought it was sky glow. This is a Bortle 3 zone, and it was transparent, but then a little bit of haze came in, and then this green that I had captured, and I'm thinking, oh, it could be sky glow. And I think I may have done this at the last Global Star Party. Real sky glow is this color. So no, that was very likely aurora. And then we come to one of Scott's favorite images. Now Orion is rising.
Oh yeah, look at that.
Pleiades, and this data here, I would love to see it more with the Milky Way and Nightscape imagers. The California Nebula here looks like a bit of a chili. I'd love to see this paid a little more attention to, because it's a beautiful region. If you can get the dust lanes to pop out, and then you combine it with the nebulosity within Orion. I even had the Witch Head. I believe that's what this is right here. Just barely some of it popped out here in this image. So it's a fairly complete image. And now taken in a slightly lesser Bortle zone, here's the other side of that, river, the Al Sabo River. On one side, I had the facing the north, we had the Lacerta region, and on this side, you've got M44, the beehive, shows up plainly. Now, tracking issues, yes, that's why these stars are a little flatter. The larger stars remain round. Here you have bits and pieces of the we call it the winter hexagon, with the bright stars that make it up. And there's still there's still details there. And so one of the challenges of doing nightscape photography is presenting something that looks the way that you would see it. And it brings me to the final couple of images. Just shows the progression from Cygnus here. Cassiopeia is a little warped because we used a 14 millimeter lens and things got bent up. So Cassiopeia unfortunately suffers. Auriga suffers a little bit here. And then you have Orion. You have the Pleiades, barely makes the photo, as well as Aldebaran from Taurus, barely makes the photo. And here you have, and the Delta Comet makes the photo, plane coming in right here. stitched together this panorama. Karim may recognize the Universally Lowbrow Astronomers sign, because that's when we went out there for Okie-Tex. My first attempt at a panorama of the Milky Way as it was rolling towards the north. Here you have the North Star, and you can just follow along the Little Dipper here, the pointer stars, I think, Dubhe and Merak of Ursa Major, pointing towards the North Star. Ursa Major drags, and a part of it disappears below the horizon, and the rest of it disappeared below here. So that, and final image, I keep showing this image at the global star parties, and every time I look at it, I'm reminded of what I actually saw, which, except for the H alpha regions that I pulled out using a modified camera here, this is essentially what I saw. You would have to darken this out to kind of get the naked eye view, but the zodiacal light crossing with this part of the Milky Way. We don't tend to go any further, because down here you actually come into more of the southern hemisphere regions of the Milky Way that you can't see in this particular view. And I'm always curious. Sometimes you can pick some things up without realizing it. I do believe light from M41 is somewhere in here, because that is Canis Major. And of course, the Rosette. There are other objects. Here's the beehive again. With the type of lens that I use, the outside stretch a little bit more than the corner, or than the center pieces do. And you've got sky glow here, as of course we're out, light pollution is not a thing. And because of that, most of this was visible naked eye, just nothing but stars. And it's something I would wish on anyone who does imaging. I would wish for you all to be able to just see with your naked eyes what's out there, and just enjoying that, and then take the image, bring out a few things that are there that you can't see, and add to it, as opposed to transforming it into something completely. You can transform it into something fantastic, and that some of the elements may be real, but then you end up with something that's so surreal it doesn't feel like something that you would see with your own eyes. And I do like to try and keep it to something that I could go outside and I'd actually see something like that, or it would that adding in things that we can't see, but all the other elements would be there, and would be at that sort of that the sizes would be correct. So that's my spiel on watching planets orbit, and watching their positions in the sky. And as far as Milky Way photography, taking pictures of different parts of the Milky Way. It's always a good idea to observe as you take your images. I come from a visual astronomer background, and so seeing it with binoculars, and then seeing what it looks like if you take the camera to it, that's just sort of the approach that I take. So thank you again, Scott. I enjoy sharing images, and you caught me in the middle of trying to fix one up. Eventually I'll do a my process video, but Gary Palmer always puts me to shame, so I'm not sure if I want to do it or not. But
Gary puts all of us to shame. Don't worry.
Right.
Good point.
Adrian.
All right.
Adrian, I would like to reserve my highest compliment to the beauty and the magic of your pictures. Your images are Mozart. Congratulations.
I am going to try and put something together using a Mozart piece. one of these days. That's on my list, along with a book that I would like to write about some of the favorite places that I've imaged. And it's definitely on the list. Thank you. That high compliment just triggered me to say, you know, maybe I can marry a Mozart piece to some of these images, and you would be one of the first to see the how that comes together. I know I can't show. I've got a slideshow with some music on it. You've seen it, David, and I don't know, Karim, if you've seen it yet, but I won't show it on Global Star Party so that, you know, we don't lose the streaming due to the you know, licensed materials. Even though I bought the songs, I don't want to take that chance with Scott, but we will.
Yeah,
but
I've run into more than once where someone claimed copyright when in fact, you know, they don't really have it. But when they claim it, the algorithms just immediately stop some of these streams. So, but thanks, Adrian. Okay, so we got our schedule mixed up just a little bit here, but I do want to introduce Beatrice Heinze. She is someone that often follows us on Global Star Party, and we always love to see her greetings and everything. Beatrice this is her first time on the Global Star Party, and so Beatrice, let me put the spotlight on you, and I'll be here with you as well. Maybe being the first time on, you're a little nervous, but we've seen your astrophotography, and we know that you do a fantastic job, and we're really, really happy to have you here. Before we get started, what got you interested in astronomy in the first place? That's a question that everybody asks. But
yes, actually, when I was a little child already, and then I had a small encyclopedia. I got it from my parents at my 8th birthday, and from then on, I wanted to learn everything about planets and astronomy in general.
Wow.
And yes, I had several hobbies actually, but astronomy and music they were always my biggest passions.
And what kind of do you sing, or are you playing a musical instrument?
No, I had a guitar and a keyboard, but I never learned to play. But I want to in the future, maybe when I find some time.
Sure.
Yes.
Sure.
Yes.
And what do you find the most interesting objects to make astrophotographs of?
I love the moon and the sun and the planets, but a couple of years ago, I was so intrigued actually by deep sky objects in the first place. But I love the moon and the sun and the planets. And yesterday, I realized that this week, Friday on the 11th of February, is actually a special day because 5 years ago, my first real telescope was being delivered at my home, and my 8-inch Newtonian. Yes. So, and that awesome. I realized yesterday, because it wasn't 2017 that I started with the purchase of this telescope, with practical astronomy and with astrophotography. The same day I was already learning how to collimate the 8-inch Newtonian.
Oh, wow. Okay,
yes.
Great. That's wonderful. Well, I'm so happy, really very happy to have you on Global Star Party, and get a chance to see you. And so we're going to let you go ahead and get started with your presentation. Thanks again.
Okay, thank you for having me. Yes, I have some pictures to show. Well, I will share my screen. This one. Okay, this is then my first setup, how I purchased it. Just my 8-inch Newtonian telescope on a Skywatcher NUQ5. And here at this day, I was solar imaging. And
hi, Beatrice. We can see, see you right now, but not the presentation.
Oh yeah, you need to share.
Okay.
It's very common.
I thought I was sharing my screen.
Yeah. We have our
Uh,
first time.
Okay.
Every one of
Okay.
us.
All of us do this.
Yes. And when I push the button share screen, it doesn't.
Share screen, and then you're going to see little dialog boxes when you hit the green share screen button. You need to click which screen you want to share, and then you need to commit to it.
Here.
There you
Now?
go. Yes,
Yes.
that's your
Now, here we
telescope.
go.
Oh, because I
Great.
don't see anything on YouTube.
Not
if you
yet.
keep
Oh, okay,
It's
okay,
just
now,
because it's
but-
delayed. It's
Yeah.
delayed. You're going to
It's a
see it about
delay.
15, 20
Yeah.
seconds later.
Okay. Yeah, this was my first setup. My Skywatcher 8-inch Newtonian, and on the Skywatcher NUQ5. And here my journey started. And I was solar imaging this day, and with a regular DSLR Canon EOS 750D in prime focus.
Okay.
And then I have some other pictures to share. Here, for example, here, yeah, I upgraded later to a real Hush Alpha telescope, a Coronado Solar Max 70
Beatrice,
millimeter.
I think
Oh.
you share the some window of the pictures of the Newtonian, and now you have to unshare to share again. Oh, here we go.
Okay,
with
there we go.
Yes, now,
There we
now
go.
okay, now I understand. Yeah, here are
look
my
at the-
two
that's
solar
fun.
setups. I upgraded in
There's a lot of
2019.
progress.
Yes, also here with the Ioptron CM60, my workhorse and my favorite mount.
Yeah,
And
nice.
here, yeah, and here the Coronado S Solar Max 70 millimeter with a double stack. And here I have my guide scope, but I also use it as a achromat telescope for lunar imaging, or here for the sun with just a regular Thousand Oaks glass solar filter. And here I was observing. I always try to observe first, and then after that to image the sun or the moon or deep sky objects. Here you see several eyepieces that I was testing out.
This is a very impressive setup.
Thank you. Now I'm gonna unshare this. And then I have okay. Oh, where is this picture actually? Okay. Is it okay now?
No, yeah, you need to click the share screen button at the bottom.
A share screen.
Share
Here
screen.
it is. Okay.
Yeah, you'll get the swing of it. All
this
right.
was my second deep sky object, a William Optics Zenith Star 61, the first generation. Yeah, and later on I installed the ZW electronic automatic focuser, an off-axis guider, and here my ZW 294 MC Pro. But till today, I still can't get the off-axis guider to work on my William Optics. So I always use my Orion ST80 actually as a guide scope, but in a side-by-side setup. So, and on the next one, share screen. Okay. And on the next up, I have here okay, does everyone see the next image? Okay, this is my latest edition actually for deep sky.
Sorry, Beatrice.
See the folder?
Yeah, because
only the folder.
You share the folder to get to show to us.
Yeah, so you click.
Yeah, you can just unshare and then go back and pick the right.
Okay.
Yeah, or you
and then
you,
now share screen.
When you share screen, put the first one above it, the first one
Okay.
window, and then that will share everything that you show.
Okay. Take this one above and then share screen. Oh,
By the way, you have a great internet connection all the way from Belgium.
yes.
That's
I
awesome.
pay a lot of for it.
I bet you do.
Oh no, I can find it. Okay. Yeah, sorry.
No, it's okay. It's okay.
Share, but then I'm going to share the whole
There we
folder
go.
again.
Here we go.
Scheduling made easy. I think you're on the Zoom.
Now,
Now?
yes.
This might work. There you
Excellent.
go.
Okay. I was showing the other one here, my latest setup actually.
Oh,
And
okay.
this is the also for deep sky. Yeah, I use it primarily. And then here with the ZW533 MC Pro, and this is a TS Optics 86 SD quadruplet Apple, a 4 elements lens. And with this one, I made actually my pictures from the Andromeda Galaxy and the Triangulum, what are actually very popular on social media. And here's my second ZW ASI Air. And because this scope is not that heavy, I always use the Skywatch NQ5, and then on the other setup is always my 8-inch Newtonian. And then I wanted to share this one. Does it come good through? Is it shared?
Yes, we can see it.
Oh, yeah.
Okay. Yeah, I wanted also to show this live video. On social media, I have already a picture displayed, the still, but because I've got so much positive feedback from this moon picture, I also wanted to show the live video. It's with the eyepiece projection method. And here you can see create a title. And even among non-astrophotographers and non-astronomers, I get a lot of positive feedback because a close-up from the moon seems to fascinate a lot of people, I think.
Yes. It's awesome.
And yes, I like it also the close-up because you can see very clearly the craters also here. And then my latest picture is actually one from M42, the Orion Nebula. It's really actual at the moment. And for the first time, I managed to get the trapezium more or less okay. Wow. Because
that's tough.
Yeah. Yes, it is tough because I did a HDR composition with exposures from 3 seconds for the core, especially, then 10 seconds, 30 seconds, and 60 seconds. But I overexposed the stars, unfortunately, during processing. But that you can always arrange later on or repair it. And the seeing was not so great, so it looks a little bit, how should I say it, dirty.
There's also a lot of nebulosity out in that area.
Yes.
It doesn't stop, So.
And here the Running Man Nebula. Yeah, that's great about the Orion Nebula because of all the nebulosity around it.
Yeah, what we may think is just, not clear or noise may actually be nebulosity that you've captured in your,
yes, also, yeah.
Yep, you've got I would call this very well done and very accurate. Everything we're seeing there is actually there.
Yes.
And especially with your, you'll see a lot of really beautiful shots, but the trapezium, that core, completely blown out because of the aim was to make the Orion Nebula as grand as possible. And those are beautiful images. Accuracy sometimes, for those that love visual astronomy, accuracy is everything in an image like this.
Yes, and I was so happy that I finally managed to do a proper core, because the other ones I will show you from earlier days. Here, for example, because this is already, the new one is already my 5th or 6th attempt. This was my first of Orion, and it was always overexposed. Here, I also forgot to use anti-light pollution filter. That's why it's so brownish. And at that time, I couldn't process a picture, so I became help from another member of my astronomy club. I was very thankful for that, because that was my biggest frustration in the beginning. And the processing, it was so hard. And now, these days, I trained a lot, and now I get, I think, some decent pictures out of it. And this was my second Orion Nebula, also overexposed. And when you see also here, my third one, maybe a little bit better and more 3D effect, but also overexposed.
Yeah, but the Running Man is very visible, so.
And this is with the William Optics and the Canon 750 DSLR. But now, I'm finally happy that I managed to get a proper trapezium.
That's great.
Do I still have time, or do you have the next guest?
After you will be a break. We'll go to a 10-minute break. So if you have a couple more images, sure.
Yeah, I can show some more images if we have some time.
Sure.
Here's for example, also the more recent ones, like this one. People seems to like a lot also the star coloring of this image. And if you look closely, you can also see some nice tiny galaxies in between, like here.
Oh yeah.
And here.
Yeah.
And
these
are also, I think, that was actually difficult, because from my previous star cluster images, I wasn't always happy with the star color. It was always so not a proper yellow or blue or also cool white. But this one, I was actually more happy with this image than my Andromeda galaxy or my Triangulum galaxy from before. And I love star colors also. I think they are underrated among astrophotographers.
Right. I agree.
Yeah. Here you can see the Triangulum, what I was talking about.
Oh yeah.
But it came out a little bit, purple, purplish. I wanted to get it more blue, but that's a learning moment for the next time. And then I have,
Let me ask you a question, Beatrice. What is the you belong to a club in the city you live in, or?
Yes. First, I became actually a club it's in Centurion, also in Belgium, about 40 minutes drive from Genk. They were specialized in astrophotography, but later on I used to be earlier in my younger years a member of the local astronomy club in the city from where I live, at the Cosmodrome in Genk. But I think in 2017 I joined the club again, and because I was starting my journey into astrophotography. And later on, I became also a board member and volunteer, etc. for the club. But due to the pandemic, the public outreaches are not so common, just like in the US as they used to be. Yes, but in the future, who knows?
Well, hopefully your friends are watching in Belgium. And enjoying this presentation of yours. It's great.
Yeah, thank you. I'll share
our audience loves it.
So. Yes, thank you. I'll share the show to my club members. Then they will get to know the show also a little bit better. maybe some of them do already.
Yeah.
Yeah, because YouTube is now, very popular medium for astrophotographers
Yes.
and astronomers.
That's right.
Yeah.
Well, wonderful.
Thank you.
Beatrice, thank you very much.
Thank you
very
Scott.
much. I think we will take a 10-minute break. It's time to go stretch your legs and get a cup of coffee. We will come back with Nathan Hellner-Mesetelman and his always engaging presentations. And Beatrice, thanks again for coming on Global Star Party. I hope you come back every time. So
okay,
we really enjoyed it.
I will. Now I'm a little bit less nervous.
Yeah. You'll get over it.
Okay, thank you.
Beatrice,
Cool.
you did
Thank you.
Well done.
All right. So
thank you, Adrian.
So we are going to transition to our intermission right now. We'll see you in about 10.
Hey, Norm. Hey, Harold. Hey, Martin. Good to see you all. Nah, Norm, we're going to get you on here one of these days. Maybe it's going to be during an after party. Thank you, Harold. It's good to see you too, albeit virtually. Exactly. You all have to have a go at presenting, taking turns. We love seeing you guys there. And Maxi's coming up later, definitely. I think he's still here. I think everybody took the coffee break seriously this time.
I'm still here, still working on this. But yeah, I'm hanging out for a little while longer.
I have to say, I was curious, Adrian, when you started talking about including Mozart, what instrument you were going to use, because I'm really hoping it's not the kazoo.
No, I just plan to find one of his a piano. I want us to call it concerto, but I'm pretty sure it's something. I wanted to find one of his beautiful piano concertos and run it as a background to some an image here. So that was the goal.
Hi, Senthil. Hey, Jeff, that would be awesome. What are you going to present to? We're looking forward to it. Anything you like, the topic, it doesn't have to be directly with the topic. It can be whatever you want to share that you've done in the night sky. That's how most of us got started, right? It's just sharing something that we found interesting that we managed to get out and observe or take a picture of, or just what we went out and looked at. Oh, hi, Naveen. It was great having you on last week. Solar imaging, oh, color me jealous.
Excellent presentation last week.
Definitely. He put a lot of work into that one. I love seeing that.
Yeah, we're we're getting the young ones coming out and sharing their love of astronomy and their knowledge of astronomy, which all I knew is those were stars and that's the Big Dipper. I haven't featured it enough in any of the nightscapes that I've taken. So I take each of these things as challenges. So
I was actually curious if you've ever, or if you're planning on trying to catch retrograde by following a planet over a few weeks and catching its orbit. That would be kind of neat to see a time lapse of not just the stars moving, but the wanderer.
yeah, and when I looked at some of the Milky Way photos I had, it was a little, the time lapse, the time in between was a little too much. So you had Jupiter here, and then the very next image, boom, it's on the other side of the galactic plane, and then boom, it's, you know, even further away. So that's actually a pretty good idea as far as, you know, capturing motion. But one thing that doesn't help me is that we have too many cloudy nights in between those times.
That's exactly our problem here. I'm glad to see, I don't know if you read, but Naveen is coming on next week, and Norm says he's ready. He's going to join us one of these days.
That's gonna will be fun to watch.
Definitely.
We're getting more and more people involved. So Karim, I'm going to send to you the final edit of the image that I was working on, or at least for now. I'm going to be sending it to you. I think this was a crescent moon and Milky Way.
The one with the Earth shine as well?
Yes.
Yes.
That is on its way. And maybe I'll send it to the RAS.
Did you get it published in the Sarnia newsletter, or in submit it for a photo of the week with Sky News?
I haven't yet.
You definitely have to start putting some stuff into the photo of the week at Sky News. I think you'll be up for voting at the next GA for some of your pictures if you do.
Yeah, so I just need I just go to a website and do it, or just do it?
Yeah, it's on the Sky News website. I will send you the link. I'll email it to you. I'll remember to do that tomorrow.
I'll be happy to. I'll submit a few of these photos. This one is ready to submit. It's closer to what I saw with my own eyes, although I couldn't quite get the glow from that crescent moon down the way I like it. I wanted to blend it in a little more with the background. But yeah, attempting to with a setting waxing crescent. And I think images like these are, I'll call it evidence that yes, you can capture the Milky Way if you have a particularly good evening. You know, the data is there, and with decent processing, you can capture a lot. And I've made the Milky Way a little brighter than my original image. In fact, I'm going to look at my original. I have my original image. And the stars look a little better, in the grass I think looks a little smoother. There's more texture. There's more texture to the grass now. And this isn't smooth at all, but
Jeff is mentioning that your microphone is overdriving.
Uh-oh.
I think it's a bit choppy is what's happening, but I'm not sure.
Okay. And I do hear an echo somewhere. It might be Scott. Nope.
Sounds like Charlie Brown's teacher talking.
Yeah.
in the background.
Wow. But
As long as he doesn't pull a Lucy during Super Bowl Sunday and start pulling the ball away or anything like that.
That's right.
you know, I've seen a Robot Chicken episode that took care of that particular case.
I
Charlie
will
Brown
say
did
I would absolutely love some psychiatric help for a nickel, though.
myself included.
For only a nickel. Yeah.
Well, isn't that what the GSPs are? They're our way of just kind of giving ourselves a little bit of a mental break.
That's right.
Yes.
Absolutely. That's what it's about.
Yay.
It's about
So, I have
connecting
an
people
idea.
around the world, but it's about, you know, certainly in this, in this time of COVID, for us to still do outreach and, you know, and for all those people that were otherwise just couldn't get out of the house, you know, so.
I can't believe Jeff is outbidding me for this help. I'm getting outbid on the chat.
Well, here we are. We're back. Thanks for giving us a few minutes here to get started. But we are going to bring in Nathan Hellner-Mesetelman. He is a master of science punism, and he is. I wish in high school I knew someone like Nathan. Because he's so comfortable in his skin. I felt, you know, I would have classified myself as kind of a geek, nerd type of person. I don't think of Nathan that way at all. But he kind of pokes fun at himself for his vast interest in science, and he has a really amazing way of explaining science with humor. Accuracy, and in doing so, he gives you new insights to understanding the universe. So, Nathan, thanks for coming on, man.
Thank you so much for having me again. I heard the theme was about orbits this time, so I decided to put together a bit of a presentation on orbital dynamics and a bit about rockets too. Wasn't too hard, not rocket science. Then again, so yeah, I'll just get this set up. So I'm calling this one alternative rockets because this was also a bit of a independent project because I just was wondering about a certain aspect about rockets I was building as a kid. So just a bit of backstory to that. When I was 11, I made a lot of rockets at home. And not anything that made it to space, obviously, but, you know, just stuff like water rockets, like those things that you pump up with an air pump, then you fill them with water and then you shoot them off and they fly. And like baking soda and vinegar or Coke and Mentos was a personal favorite of mine. People have said, oh, that's not actual rocket science. But despite the fact that homemade rockets can't really compete with regular rockets, that doesn't mean we can't compare the two. And I don't think I ever actually considered how well these homemade rockets would work if someone used them as a legitimate propulsion technology. So the real question here is obvious. If you were marooned in space, specifically in low Earth orbit, and you had just a homemade rocket with you, say like a soda bottle or something, the question here is, would you be able to produce enough thrust with that to bring you back to Earth safely? Or if not, how big a rocket would you need? So to make any kind of approximation about that, I need to bring in the half Greek, half English, 2-letter long word that is the core of all rocket science. So yes, pronounced delta V, or delta V by enthusiastic rocket scientists. It's defined as how much a rocket can change its velocity. And it's pretty important because it allows people at NASA to make extremely accurate determinations about how much fuel they can use. It's also the only way to get really good at the game Kerbal Space Program. So that's pretty good too. Delta V basically means, how much you can change your velocity. So if you have 0 meters per second of delta V, that means you have no fuel. You can't go anywhere. If you have 100 meters per second of delta V, that means if you used all your fuel, you'd be moving at 100 meters a second. So first of all, some rules before I imagine this scenario. We're assuming you can survive atmospheric re-entry. That's not something that can actually happen, but for these purposes, it'll work. And also, you just have a homemade rocket. You don't have anything fancy, so no thrusters, no guidance systems, no control panel. That means it's not as straightforward as flying a spacecraft. And I'm not saying that flying a spacecraft is straightforward. So to calculate how well each rocket would work, I just watched some videos of some of the old rockets I built, and then measured how fast the fuel, or most often fluid from baking soda, vinegar, or water, was leaving the rocket. And then I used a modified version of the rocket equation and just imagined everything for a homemade rocket, but just bigger. So here's the equation. Oh, and one thing I should mention, physicists have a bad habit of assuming that everything is spherical. I don't know if you guys ever noticed that, but it's like, assume this is spherical. So I'm assuming that the rocket's going to be spherical. And this is the equation you'd need. Don't ask me why, I just decided to accept it. And so with this equation, here are some homemade rockets and how they may save your life one day if you happen to find yourself marooned in low Earth orbit. Baking soda and vinegar. So the first rocket I ever built was when I was in grade 4, and it was a little canister. And I poured, it was filled with vinegar, and I poured the baking soda in, sealed the end, put it down on the table, and ran for my life. And if you had a larger version of that in space, it could actually save your life. So to get back to the top of the atmosphere, which means just to lower your orbit enough that you skim the top of the atmosphere where air friction can do the rest, you need to slow down by about 60 meters per second. Using a baking soda and vinegar rocket, you could do that with a spherical rocket 11.25 meters wide, which is about the same size as the Russian Soyuz capsule and the newly created SpaceX Dragon capsule. I want to see a space program fund that, because that would look absolutely awesome. So it's not implausible, but you should probably opt for better propulsion technologies. So the next one that I thought of was Coke and Mentos. It's a lot like a liquid rocket booster now that I think about it, because it has fuel, and then it has it's not really oxidizer, but it's as if it was oxidizer. You mixing the two together, they react. It's much more efficient than baking soda and vinegar. So you'd actually only need a bottle 3.22 meters wide to get back to Earth, and a mechanism to insert thousands of Mentos per second. So if you can develop that tech, then you're good. So these techniques work for saving you if you're stuck in low Earth orbit, but they don't really work that well if you want to go farther than that. For example, if you wanted to accelerate by 535 meters per second, which is about how fast you'd need to go to raise your orbit by 1,300 kilometers, your Coke and Mentos rocket would expand to nearly the size of Earth, which is impractical. Having a rocket the size of Earth is not easy to build or control, and there are better ways to get around in space. My personal favorite was water rockets, because I did a science fair project on it last year, and I really like just launching water rockets. Some of them have gone maybe 100 meters. None of them have made it to space. So I was interested to see how this would work out mathematically. So to get to save yourself and travel back to the surface of Earth from low Earth orbit, you'd need a water bottle 80 centimeters wide. I was surprised at how small a water rocket you'd need. But I guess you don't need something bigger than that to accelerate to 60 meters a second. Given how well this would work for getting out of low Earth orbit, it made me wonder if it could take you further than that. And I started thinking maybe Apollo mission style using a water rocket. So to leave Earth orbit and intercept the moon, you need 3,940 meters a second of delta V. Unfortunately, this water rocket, 80 centimeters wide, can only accelerate you 60 meters a second. To reach the moon, you'd need to add more water to move faster, and more water to push the water to move faster, and more water to push the extra water to push the extra water to move faster. And as you can tell, that is the tyranny of the rocket equation. Eventually, you would reach a rocket that had enough water to push all of itself to intercept the moon. The bad news is it would be 3,092,000, not meters, not kilometers, but light years wide, which is slightly less practical than even a Koch and Mentos rocket the size of Earth. Given the density of water, this container would weigh significantly more than the observable universe. Ignoring the obvious inconsistencies with a container of water this big, it would cost a fair bit more than many space agencies would be willing to fund. Given the cost of transporting water to orbit, it would cost something like 3.7 times 10 to the $75 to ship everything up to orbit to supply the ship. That's enough to fund 10 to the 65 complete lunar expeditions using regular rocket fuel. The container of water would also immediately collapse into an ultramassive black hole, consuming the entire universe, destroying absolutely everything. So I think it's best to say no-go for launch for that one. If you happen to be in a situation as bad as this, I would just say the moral of the story is to get yourself home if you're stuck in space with a water rocket, and not to try to go to the moon with a water rocket. My next idea was using Nerf guns, because I used to have Nerf gun battles with a friend in grade 8. And for this, we have to change the equation, because the equation before assumes that the liquid takes up 100% of the available space, and it does because it's a liquid. Nerf gun darts are not liquid, so you have to add a section for packing efficiency. And that just means Nerf bullets don't pack 100% efficiently. There's air left over once you put them all together. For cylinders, which is approximately the shape of a Nerf gun dart, that happens to be about 0.9, so 90% packing efficiency. And with that, you are good to go to keep doing the calculation as usual. So foam dart guns, they're popular kids' toys due to the fact that dart guns shoot foam darts, and certain children enjoy the satisfaction of using foam darts to hit certain people while they're writing scientific articles. But in all seriousness, I was wondering if these could be used as rockets. So if you were marooned in low Earth orbit, but you had a Nerf gun, I don't know why you have a Nerf gun, but just suppose you do, you would only need a container of foam darts about 1.5 meters wide. That's not totally implausible, but it would be pretty hard to shoot them all at once. Nerf guns, they only hold like, I've seen some that hold like 6 that you can just pull and shoot, pull, shoot, pull, shoot, and only 6, and then it takes like a minute to put them all back in because they're kind of finicky. You'd probably want to, if it takes you a few minutes to reload, you'd probably want to only shoot during the, I think it's called a Hohmann transfer window. So you'd want to shoot all your darts when you're at the same point in your orbit. So you have to like shoot your foam darts and then wait until you come around again and then shoot again. Given that your container, about 1.5 meters wide, would contain about 100,000 darts, you'd be stuck up there for several weeks just shooting until you got back to Earth. But if you could do that, well, that's fine. But you'd have long run out of darts by that point. So shoot, would you say? My last type of rocket that I looked at was about popcorn. Now a popcorn rocket would definitely look popping. And I have to say something about corn puns. They're pretty corny, but about popcorn rockets. Popcorn is a great fuel intuitively because you can store it in a small space. And then once you activate the fuel, it suddenly balloons up and produces a whole bunch of thrust. So popcorn, I mean, it sounds great, but it's actually not as great as it sounds because popcorn is really heavy when it's in its seed form. And even though the seeds explode, you'd still need a container 36 meters wide to get out of low Earth orbit. That's impractical. And if you made it a cylindrical rocket, it would be a little larger than the Saturn V just to get out of low Earth orbit. I mean, Soyuz spacecrafts can do that with a container like a fuel tank 2 or 3 meters wide. So popcorn's not the best fuel to use. But I mean, it's still fun to think about. And it also made me think about maybe you can go farther than low Earth orbit too. So if you wanted to go to the moon, an Apollo style mission using popcorn. Of course, the tyranny of the rocket equation, the rockets get really big. And for popcorn, it's really, really big. Yeah, if you wanted to reach the moon using a popcorn rocket, your rocket would need to be about 6.97 times 10 to the 268 times wider than the observable universe to reach the moon. It's just crazy. I don't think this is a good idea, but it comes with a plus side. You could actually save considerable popcorn by not landing on the moon, but simply intercepting the moon's orbit and performing a flyby maneuver. Landing on the moon actually requires a huge amount of fuel. It uses up almost half of the fuel that you'd have at that point. So if you decided to forego the landing and just pass the moon by, it would significantly reduce the size of your rocket from, well, like I already said, 6.97 times 10 to the 268 times wider than the observable universe, and reduce it to only 4.6 times 10 to the 186 times wider than the observable universe, which it definitely doesn't sound that much more convenient. And unfortunately, it comes with a downside. All of these calculations are based on the assumption that you aren't losing any fuel in the process. And this cartoon portrays how you may lose fuel in the process. So if you eat any popcorn along the way, sorry, you're screwed. So in conclusion, I wasn't surprised that homemade rockets didn't work as well as rockets that are built by the United Launch Alliance or NASA and other engineering companies. It also makes sense why NASA does hire ULA, or the United Launch Alliance, to build their fuel tanks and not soda bottle companies. So yeah, since many space agencies feature scale comparisons of their rockets to showcase their achievements, I decided we should do the same here. I was a little let down that none of the rockets mentioned throughout this chapter could be used to get to further places like Mars. Okay, well, actually, I did run the calculations for places like Mars, but as you can probably tell, they're so ridiculously obscure, they don't really help to add clarity, which is why I didn't include them. Of course, now you're just dying to know about getting to Mars, so I decided to add them anyway. So getting out of low Earth orbit simply requires you throw a bunch of mass in the opposite direction you're moving in. And then after that, you re-enter the atmosphere and, well, die if you're not protected, but you return to the surface if you are. And from what we've just seen, using water rockets or even popcorn rockets to do this, while impractical, it is plausible. Getting to the moon requires getting out of orbit, intercepting the moon, getting into low lunar orbit, then deorbiting from there. And as we've seen from this, homemade rockets sometimes become larger than galaxies in order to do this. Getting to Mars is much, much harder. Getting to Mars requires entering low Earth orbit, leaving Earth's orbit, entering solar orbit, performing a Hohmann transfer once to get to Mars's orbital velocity and a second time to match Mars's orbital speed, then intercepting Mars's gravitational sphere of influence, then entering Mars's orbit and then deorbiting from there, then decelerating to reach the surface. Then you've landed. To get to low Earth orbit, escape Earth's gravity, do a Hohmann transfer, enter low Mars orbit, and decelerate all the way down to landing on the surface, you'd need 9,510 meters a second of delta V. And in order for a water rocket to do this, it would only need to be 92 billion times wider than the observable universe. I say only because when you think about how huge some of our other rockets got just to reach the moon, a 92 billion universe-wide rocket is actually quite plausible. If you wanted to repeat the same maneuver with a spherical popcorn rocket packed full of popcorn kernels, you'd need a container 3.97 times 10 to the 449 times wider than the observable universe. Sure, it wasn't convenient before, but this is really pushing it. And just for the heck of it, if you wanted to do all that and return to Earth, you'd need 15,220 meters a second of delta V. And that's assuming you use aerobraking to slow you down. To do all that with a popcorn rocket, have you ever heard of the number a millillion or something? I don't know. Well, this is close to that. Your popcorn rocket would need to be 3.98 times 10 to the 718 times wider than the observable universe, a number so unimaginably mind-bogglingly huge that the only thing that comes to mind is that error 1 that you get on a calculator when the computations just cause it to overflow. Except there's one use that you could find. So NASA uses specialized fuel pumps to quickly drain the fuel from a rocket if they need to abort the mission to prevent what they call a rapid unplanned disassembly, or an explosion if you want to use technical terms. Similarly, you could use one of those pumps too. And if you took one of those pumps and attached them to your rocket, you would be the guest of honor at any movie night. And with that, I end my presentation. Thank you so much for having me. Just a reminder, I am on Instagram and I have a website, nerdanomaly.ca, where I post my cartoons as I've included in this presentation. Thank you so much for having me.
Thank you. That was hilarious.
That was amazing.
It's hard.
Excellent presentation.
Anyways, it was awesome. Awesome.
Thank you.
I love the that you can get to these giant, mega enormous numbers, Nathan. It's but on top of it, as you're making these presentations, I would be in fits of laughter the entire time. So, but thank you very much. And we look forward to having you again on Global Star Party, Nathan. It was awesome.
Thank you. That's one of the things I love about math. You can ask them the weirdest questions, using math.
Right.
You just get an answer. It's great.
So actually, Nathan, and I may be able to learn something from you with this one. You mentioned that the equation is necessarily spherical, and I found that interesting. I saw a pi in the equation, and I was just curious to know if that is how you can tell it's a spherical equation, or how how we figure that out.
Well, you can tell it's a math equation because it has pi in it, because every math equation seems to have pi in it. It just shows up everywhere, doesn't it?
Right.
You can tell it
but
has
spherical.
Something circular to do with it. And if it's 4 pi r cubed, then it has something spherical. And I believe that equation incorporates the sphere volume equation into it.
Okay.
And then again, I'm not sure because
it's in the density relationship. Yeah. Nathan, did you want to talk a little bit about the cosmic generation before you finish up?
Oh yeah, sure. So yeah, I guess we're still working that out, and I still have to finish setting up the announcement on my website about it as well. But I guess I'm working with the Denver Astronomical Society and an Explore Alliance, and we are setting up a international astronomical organization for youth that are interested in astronomy, and created by youth who are interested in astronomy. So I'm working with 6 or 7 other space nerds such as myself to set this up, and I'm really looking forward to when we can start doing routine workshops about this. And I believe Tara's workshop is the first official meeting. So I'm looking forward to that.
Great. Well, thank you very much. Thank you. You know, anything that can help these programs move along is wonderful. And, you know, at Explore Alliance, we'll continue to do what we can to support that. So it's great. Thank you.
Thank you.
Up next is Deepti Gautam from Nepal. So we are stretching around the world. We've gone from Europe back to the United States and back to North America, and now we're out to Nepal. Deepti, what time is it over there?
It's 6 a.m.
6 a.m. Wow. Okay. So you're up
8 a.m.
Okay. So thank you for coming back on. You know, we love your presentations. We love your poetry. I know that you're very much involved with Nepal at the Nepal Astronomical Society there. And,
Yeah.
you know, so how are things going in general for you?
This day I'm not involving in astronomy and all because of my study.
Yes.
But I'm working as a mentor in the asteroid search training, where we give the training to how to search the asteroid with the help of software like Astrometrica, and how to detect the asteroid. So recently we have given training to 30 students, and from the remote area of Nepal, and their response was very nice. They were very excited to learn how to detect the asteroid. And similarly, Nepal Astronomical Society is now involving in one research program, that is a MILSET MILSET research, and this day, and just now the Olympiad has been completed, and so again the Olympiad program is coming, and all the people are from the Astronomical Society are involving in the research program right now. And I'm a bit busy this day for my study, so I'm not giving much time. So I was thinking about joining a Global Star Party the next previous week, I think, and I got an email. I read an email that Star Party is postponed because you are vaccinated or for that. And so yesterday I was just planning to email you, and I saw your message, and I responded at that moment. And today as our theme is orbit, I have prepared something about that. As we know, this orbit in celestial mechanism, I want to go through the celestial mechanism. In orbit is the curved trajectory of an object, and such as the trajectory of the planet around a star, or of natural satellites around a planet, or often artificial satellites around an object or position in space, such as planet, moon, asteroid, or Lagrange point. Within the planetary systems, planet, dwarf planet, asteroids, and other minor planets, comets, and space debris orbit the systems in elliptical orbits, a comet in a parabolical or hyperbolic orbits. About barycenter is not gravitationally bound to the star, and therefore is not considered part of the star planetary systems. And body that are gravitationally bound to one of the planet in a planetary system, such as natural or artificial satellite, follow orbit about a barycenter near or within a planet. And there are different types of orbit, such as geostationary orbit, and low Earth orbits, medium Earth orbit, and polar orbit, and sun cycloid orbit, and transfer orbit, or geostationary transfer orbit, or Lagrange point. And geo is a geostationary orbit. Geo is used by satellite that need to stay constantly above one particular place over Earth, and such as telecommunication satellite. This way, an antenna on Earth can be fixed to always stay pointed toward that satellite without moving. And it can also be used by weather monitoring satellites, and because they can continually observe specific areas to see how weather trends emerge there. Unlike satellites in geo that must always orbit that orbits along Earth equators, and LEO is low Earth orbits. Low Earth orbit satellites do not always have to follow a particular path around the Earth in the same way. Their plane can be tilted. This means there are more available routes for satellites in low Earth orbits, which is one of the reasons why low Earth orbit is commonly used orbit. And similarly, there is another orbit, that is medium Earth orbit. Medium Earth orbit comprises a wide range of orbits, anywhere between low Earth orbits and geo Earth orbits at geo. It is similarly to low Earth orbit in that it also does not need to take a specific path around Earth, and it is used by a variety of satellite with many different applications. And there's another orbit, that is SSO, that is Sun synchronous orbit, is a particular kind of orbit, polar orbits. And satellite in SSO traveling over the polar regions are synchronous with the Sun. This means they are synchronized to always be in the same fixed position relative to Sun. This means that satellite always visit the same spot at the same local time. And there is transport orbit. Transport orbit are a special kind of orbit used to get from one orbit to another. When satellites are launched from Earth and carried to space with launch vehicles, and satellites are not always placed directly on their final orbit. Often the satellites are instead placed on the transport orbits, and orbit by using relatives little energy from built-in motors. The satellites or spacecraft can move from one orbit to another. And this allows a satellite to reach, for example, high altitude orbit like geo without actually needing the launch vehicles to go all the way to altitude, which would require more effort. This is like taking a shortcut. And reaching geo in this way is an examples of one of the most common transfer orbits called geostationary transfer of O Lagrange point or L point, or allow for orbit that are much farther away, over 1 million kilometers, and do not orbit is Earth directly. And these are specific point far out in space where the gravitational field of Earth and Sun combine in such a way that spacecrafts that orbit them remain stable and can thus be synchronized relative to Earth. If a spacecraft was launched to other points in space, very distant from the Earth, they will naturally fall into an orbit around the Sun, and those spacecraft would soon end up far from the Earth, making communication difficult. Instead, spacecraft launched to the speed L point stay fixed and remain close to Earth with minimal effort without going into different orbits. Yeah, this is I prepared something about the orbit, and our small poem written like: the night is come but not too soon. The night is come but not too soon, and sinking slightly. All silently the little moon dropped down behind the sky. All silently the little moon dropped down behind the sky. There is no light in the earth or heaven but the cold light of stars, and the first watch of night is given to the red planet Mars. Is it Tender's star of loves? Is it Tender's the star of loves, or the star of love and dreams? Oh no, from the blue tent above, a hero Amos gleams. Thank you.
Thank you so much. I love those. I love those presentations and the poetry.
Thank you, Scott.
Deepti, thanks again for coming on. It looks cold. Is it cold where you are right now?
Yeah.
Yeah. Okay. Well, hopefully you stay warm and and enjoy your studies. I know that you're a great student, and we love it when you come on. We know that you certainly understand your subject matter, and you present it very well. And I hope to see you in the United States at one of our universities in the not too distant future. So that's great.
Yeah. Yeah, I'll be there very soon.
Pretty soon. Okay. All right.
Yeah.
Let me know where. Okay. And
Okay.
we'll invite you to one of our star parties. That's great.
Okay, sir.
Okay. All right. So up next is Dr. Marcelo Souza from Brazil. Marcelo is a cosmologist by training, and he is a professor of astronomy and physics down in Campos. And we are so glad to have him. Marcelo is also the editor, senior editor of Skies Up magazine, our global astronomy magazine that is available for a free download. So, Marcelo, thank you for coming on to our 82nd Global Star Party.
Thank you very much for the invitation. It's a pleasure to be here. And today, Scott, I would like to talk about something that we live near the coast here. Then something that many people have doubts about is about tides. And few people know that the tides are also associated with this movement, the motion of the system, Earth-Moon. It's not only caused by the influence of the gravity from the moon and from the sun. We have also 3 factors that you have to consider. And I will show this. Here in Brazil, we have a place that the tides change like this, like I'm showing here. It is the north region of Brazil. I think that is the second or third place in the world that you have difference between the low tides and high tides so intense. You can see here in this image. I saw this happening. In one period of the day, we have all the boats leaving the port, and 6 hours later, you have to wait more time to have the boat, because the boats can't travel, because you don't have water, almost water there. It's in a place that you call the state of Maranhão in Brazil. Is in the capital of Maranhão, that is São Luís. Something like this happens. Then you have time to leave the port.
Wow.
And what causes the tides? This is something that many people don't know, because they consider that influence is only caused by the difference of the gravity force from the moon and the sun in different positions on the Earth's surface. Then we know here, this is something not in scale, but you have the orbit of the moon and the orbit of the system, moon and the Earth around the sun. Something like this. This is the ecliptic. Here is the equator, and here is the orbit that is 5 degrees inclination in relation of the ecliptic. It's not like we see here in this image. Oh, sorry. This is what happens as the causes of the tides. You have here, I'm not considering the sun here, on the moon. The body center between the moon and the Earth, it's not in the center of the Earth. This is something that we need to consider, because when I have here the Earth and the moon, here is not in scale, but you imagine here the body center is not in the center of the Earth. It is within the Earth, lies within the Earth, but it's not in the center. Then when the moon moves around the Earth also have a motion, do like this, because it's not in the center. And we have the experience here. As we are in a rotation system that is a system that's rotating, we have a centrifugal force acting here. We feel this. This is something that my students and many people ask me when they see the images in books that you have high tides in the both sides of the Earth, in the side that is in direction of the moon and in the other side. Why that you have in the both sides? The reason is that, as you see here, you have the white arrow here. It is the difference, the force of the gravity caused by the moon in the Earth's surface in one side and the other side of the Earth. And here you have the blue arrow is this effect that we feel because of the motion of the system Earth, Moon, and what we feel here in the Earth, because the body center is not in the center of the Earth. Then when you found the resultant here, the result of the two forces, in this side, the green, you have a force in this direction. And in the other side, you have a force, a result force in this direction. Then this is the reason that you have tides in both sides. In the side that is in direction of the moon, the force, the gravity force from the moon on the Earth's surface is bigger than this influence of the motion of the system. And the other side, you see that this centrifugal force is bigger than the force of gravity here. You need to consider that the centrifugal force only we need to use this term because it's an inertia force, and only some kinds of systems that you need to consider this force, but it's only the inertia because it wants to leave the Earth. It's something like this. And as we are in a system that's rotating, then we had to consider this kind of force to explain what is happening, like the Coriolis force also. That is an inertia force. And here, what's happening? We have two kinds, generally, of tides. You have the CZ, eu acho que this is correct term in English. I don't know if I said correct. That is spring tidal, spring tides, like CZ tides. Is when you have the new moon and the full moon, because the moon and the sun is in the same line. Only for explain what's happening, same direction. And you have quadrature and the nip tides when we have third and the first quarter of the moon. What is the difference between them? You have low tides. The high tides are not so big as you have during the syzygy of the spring tides, as I show here, because you have tides here caused by the sun, that is small, and here from the moon. This is something that is amazing because we see this image that have the water almost leaving the Earth. And I saw, I had here, I didn't find to show, a book that they explain what's happening here, saying like the water is floating. It's flying, and between the water and the surface of the Earth, you have a vacuum there. Something unbelievable that they put in a book because they didn't know how to explain what's happening. Why you have a high tide in a region of the Earth and a low tide in other region, then when the Earth rotates, this change. And this is something easy to explain. I'll show here. This is some, here is in Portuguese, you have baixa mar, that means low tides, and pré-mar, that is high tides. Show also because you need to know the direction of the force between the Earth and the moon, the gravity force, and then you see that when you are near the equator, you have high tides, then you are far from the equator. Depends on the periods. when of the year. Here is the period of you have Syzygy, that is spring tides. Here is quadrature, that is the nip tides. And what happens is this, it's like a wave. It's a movement, the water moves from different region of the earth to other region. It's only this that happens. And you have books that show a lot of explanations, like the unbelievable explanation that I said that I found in a Brazilian book about tides, that they almost, they say that the water is not touching the soil, the surface of the earth during the tides, something that's unbelievable. And here what happens is, because the force, direction of the force is from to the center of the moon, then you have components in two directions, and one of the components is what makes the water moves to this direction. Then you have a high tide here, and you have a low tide here. I don't know if you see my the mouse here. I'm moving the mouse. I don't know if you can see the mouse.
Yeah,
but
you can see. Yes.
Here have low tide here, and here have high tides. And the earth rotates, this change. And this is the reason that changes during the day. You have this movement from a part of the earth to the other part of the earth, according to the rotation of the earth. I know that is not so easy. So here I show something. Let me return here. It's more complicated, I try to show easier, but I think that's what is important to know, that you have three causes for the tides. It's not only the difference between of the gravitational force in one side from the other side of the earth, caused by the sun, the earth, and also by the motion of the system Earth, Moon. This is the reason of this side. And caused because the body center of the system is not in the center of the earth. Because we are preparing activities for the eclipse, then you have to, I'm talking about, we are studying with the students the effects that you have on Earth, caused by the gravitational fields of the moon. And this is something that's important to know, as we are also near the coast. And we have tables of tides here. And I want to remember that we have a total lunar eclipse here in May 16. We are preparing the activities. And one of the activities I show is this, to measure distance between the Earth to the moon in the moments of the eclipse. And we are looking for partners to make this project in different countries. And if someone wants to also be involved, it will be great. Because it is an experience that can motivate students in schools to participate. And we now are returning our project, that Young Stars of Tomorrow in schools. We are planning this year to visit 50 schools until October. Then this month we will visit 40 schools. And we are not visiting more schools because we have Carnival here in February. At the end of February, that everything is closed here in Brazil. But this moment we don't know what will happen because of the COVID. And maybe we don't have dances in the streets, but we have the holiday. This is very difficult to avoid. And this is our partners. And in the period from April 22, 23, we have our international meeting. We would like to invite everybody to be participating. Everybody will be very welcome here. Thank you very much, Scott.
Thank you, Marcelo.
For the invitation.
Thank you. I have a question, Marcelo. Will the presentation, the 14th event, will that be broadcast?
Yes, we do both. We do in person and online.
So a hybrid event. That's great.
Yes,
That's
hybrid
wonderful.
event because after the COVID, to
Yes,
organize them.
right. I think most meetings like that, a lot of events are going to be hybrid events. So we're looking forward to doing our first as well. So that's great.
It is continues difficult here, the situation because of COVID. I hope soon we'll have better times. No? I hope.
Excellent. Excellent.
Thank you very much,
so much,
Scott.
Marcelo.
It's a pleasure to be here.
Thank you. Okay. All right. So up next, we will have Gary Palmer from up in the UK and Wales. And Gary is a master of telescope setup, astrophotography, Pix Insight, name it. You know, he is the go-to guy for a lot of people in the industry that want to get their equipment tested. I mean, just look at all the equipment behind him right now. It is an amazing arsenal. You know, people have asked on our programs, Gary, what do you know about such and such camera? And he'll go, oh, like this one, and pull it out of his equipment cabinet. So it is impressive what he does, but even more impressive is what he shares with our audience about learning the craft and skill of image processing, of image capture. And if you want to learn about astrophotography, you know, look no further than Gary Palmer. Gary, thanks for coming on Global Star Party.
Thanks for asking me on. Hi to everybody. Hope you're all well. It's been quite a while, I think, since I was last on. But weather's been absolutely rubbish here. That's the only way I can put it. The jet stream's moved up north, so we're just getting the residual of storms coming across, and I can't remember the last time I saw the sun. I'm sure it was about 3 weeks ago, something like that. So it's been a little bit of hard work here, but we have been moving through different things and sort of going along with stuff. In between, there's really not masses to talk about, but there's a few bits that we've been doing. So I'm just going to set up a couple of little bits on here. There we go, and I'll share the screen over. Hopefully you can see that image there. Yeah, that's little solar flare going off. But this was a single frame from a mosaic. It's created, I think it was about the 14th of January, something like that. So we go across the sun, and we take 12 of these, and this is really hard from the UK in the winter because the sun's really low. Yeah, and we really sort of struggle with this thing. But if you work it out correct and you fiddle with the images a little bit, then you can start to create a mosaic. So it ends up coming out like that. That's 12 of those single panels joined together and then working across. And what I've always found with doing the mosaics is to go across the sun from left to right. So you go across and make sure you have a good overlap. So you want a good 20% overlap on each side. Then you can crop off the edges, crop off the stack lines, and you can get these together in Photoshop or lots of other programs. You can put them together. Microsoft Ice does a good job on smaller mosaics. If you want to add the color into it, then it's going to look something like that. Yeah, so that makes it stand out a little bit more. Everybody's a bit different, but this was done with the double stack system that I showed everybody probably about September, something like that. And that's basically putting the quark on the back of the lump so that it brings out a lot more contrast in the images. So that was that. We got all of that up and running and working. I also showed the Rotarian system, which was this system last year that we developed. So this is all up and running now. And these were the first sort of test shot images out of this. So each filter here will rotate around. It's all controlled via the computer, and we will have ASCOM drivers to run into the software. But effectively, when I tell it what filter to go to, it rotates around, and therefore you get no issues with the camera rotation or rotation of a sunspot while we're imaging. So that's a magnesium image. This is one of the test images coming out of it. And again, it's winter time, get into midsummer. This is going to be a lot clearer. And the system that is going over to Spain is going to be even clearer because it generally has nicer weather than the UK. So, but looking at the same sunspot group, we're in magnesium there. We can go to sodium. Then we can go to hydrogen alpha. So these all share very similar Barlows, telecentric Barlows in the quarks. So it gives you a very similar field of view. Now, they don't actually make a quark with the same Barlow in for calcium. So that is quite hard to work that out because calcium's the worst wavelength to try and image through a poor atmosphere. So generally you don't get clear images. But with a bit of playing around, we've got the calcium up to about that level there. So again, once it gets into summer, this is going to be more or less the same field of view for all four filters. And then it just gives you the choice. If there's different activity going off that you can see in different wavelengths, that sort of works out quite nice. So that's coming along well. System behind me that is going out to Spain, that should be ready by the end of this week. For imaging in the UK, not a lot. Had a quick test of Orion, did that a couple of weeks back.
Wow.
And this is just literally an hour's worth of data. You can see the high clouds gone over because it's just bloating out the stars a little bit. But when you're not getting a lot of clear weather, this is what you have to put up with. Is just literally grabbing an hour or two whenever you can. So that was that. Now, apart from that, I've been working on some other projects and I thought I would sort of run into a little bit more detail with that at the moment. If we bring up PixInsight, there we go. This is a current project that I'm working on at the moment. This is data from one of the regular contributors on the Star Party in the sense of commenting and different other things. And that's Jeff Wise. So Jeff Wise has taken this data.
Wow.
Out in California. It's about 29
Super,
hours
Jeff.
there.
Jeez.
And then sent me the raw data over. So at the moment we're working through this. So this is taking quite a bit of processing, as you can imagine. So if I zoom out there to the full image, it's taken on a Stellarvue 152 with a ZWO 294 mono and then chroma filters. We have got the full set of filters go into this, but it's a case of building this a bit at a time. And this is really just getting the image together, just to have a look at the data. So if we come back down a little bit and have a look at some of the other filters that are there, we can see what's going on. So I've brightened these up just so that we can see really what's happening in the background there. And we can see the different data. So like the hydrogen alpha data, you can see what's going on and so on. So it is a case of spending quite a bit of time processing these, cleaning these all up, then getting them ready to integrate and then starting to integrate them into a palette. So that image there and the other one that disappeared, there we go. What you can see, what you normally don't see in a lot of these images is this generally ends up as quite a black hole. It's the center of the Rosette Nebula. And generally when we're imaging it, we're not this close. So therefore you don't see it. And also it's having the amount of data that Jeff's managing to capture. So there was a little bit of high cloud going through this. You can just very faintly see it around these stars, but it's nothing we can't correct as we move on with the data and work this out. This really is a test image. So if we zoom in a bit closer, somewhere around there, we can start to move up and start to look around at the detail. And wow, you see a lot of this is coming out now, three-dimensional.
Yeah.
It is quite drawn out processing something like this. It's not a 5-minute thing. and also the capture. You know, Jeff's doing a pretty good job out there capturing this sort of data. And you could take out really any part of this image and you're sort of looking at it for quite a long time and going, wow, there's a lot of stuff in there that you don't normally see. Yeah, that's the sort of key thing. So just move across more to the center part. So you can see the detail that's in this. It's pretty stunning at the moment. And I know Jeff's beavering away at caching some more data because I've got a link which is downloading to give you an idea of how long it takes to download some of this data to send it across the world. One of the sets that's coming over now is about 24 hours to get it over here. So there's a lot of files in there and a lot of stuff to run through. But we'll work on this a bit more over the next couple of weeks. There's also some nice V-band data to have a look at and to add in there, and then we'll manipulate the colors around a little bit more. But that's been taking up a fair amount of time to get this together at the moment. So apart from that, not a lot else has been occurring here. It's all been pretty straightforward because of the weather. So
I think we're all blown away by those images, and as always, Gary, it's a pleasure. So
thanks. It's like I say, it's just weather at the moment. Can't really do a lot. We've got a backlog of stuff here to test. We're due to get some sun Thursday, Friday, and both of those days are fully rammed with solar testing. Yeah, so it's just going to be a case of grabbing a few images in amongst everything else. But yeah, it's always good fun.
Great. Now, for those of you that want to learn more about image processing, I did put in the link to Astro courses. Let me see if I can do that again here. Here it is. And so Gary does one-on-one tutorials, and he can definitely take you to the next level if that's what you're looking for. So really
also keep an eye out.
that,
we do some stuff with you. We also do some stuff with Ontario telescopes. So we've got courses running out there. Beyond imaging, we're running some big workshops over the next month. There's some of those still around. So we're not just sort of based in the UK. There's stuff going out all around the world. We've got customers at the moment in Hong Kong, Israel, Poland. They're literally right across the world. So yeah, it's fitting it in around everybody's time zone at the moment. That's the main thing.
Right. Well, thanks again. And we look forward to having you on again on anytime on Global Star Party, Gary. Thank you very much.
Cheers. Thanks, Scott.
Thanks. Take care. Okay. Up next is a dear friend, Rachel Freed. I met Rachel at the Northeast Astronomy Imaging Conference. We did a little presentation together, a little video that you can still find on YouTube. And and then I met her again at the one of the very early, the forming meeting for the Alliance of Historic Observatories at Mount Wilson under the 100-inch dome. And I think that is something that neither one of us will ever forget. It was a very historic meeting. With George Ellery Hale's grandson was there, Sam Hale, and directors of these historic observatories were all there, and it was just incredible. So, but Rachel, today we're going to talk about the Institute for Student Astronomical Research, which you're the president of. I assume you're the founder as well. And so thank you for coming on to Global Star Party. It's your first time, but it's not your first time to give presentations. So
it's not.
Tell us about these students and what they're doing, and how you're changing lives.
Sure. Okay. Thank you for having me on. Can you hear me okay?
I can hear you just fine.
Okay, great. So the Institute for Student Astronomical Research, I actually am a co-founder with Russ Jenni, who is one of the first people to automate robotic telescopes.
Right.
So I have slides to share, so I'll share my screen here. But the main idea, let me get our faces off there, hang on. All right. We work with students to do basic double star astrometry, and I'll talk about that in a moment. But the idea is to get students involved in research sort of as soon as we possibly can in their young educational careers. So I work with a lot of high school students and community college students and university students. I also work with their teachers, with university professors and high school teachers who want to provide research experiences for their students. So this was my first experience doing a double star research project with my students when I was a high school teacher. And just to give you a sense, it was really hard. I was new to this whole thing, but I knew I wanted students, I could see that they wanted to get involved in the actual sort of the meat of scientific research. And let's see, next slide here. All right, so what we actually study are double stars. Now, this is just a little animation. The stars we study, their orbits are much slower. They tend to go around each other in hundreds of years or thousands of years. But this is just to give you a sense of an orbiting situation. And we study stars that have been studied sometimes 100 or 200 years ago, and we'll take an image of where they are relative to each other now. And for example, what we'll do is we'll take an image of these two stars and we'll measure where they are, how far apart they are relative to each other, and what the angle they make with each other is currently, and compare that to historical data. So here in this second diagram, there's the central star, and then the other star over 100 years or so has been making this orbit, and we can add a data point. And so students are collecting original data and adding to historical data to really create these orbits or refine them, or in some cases show that actually an orbit that was calculated isn't correct, and maybe the stars aren't even orbiting each other, but it took 100 years of data to figure that out. This is the only actual image. I've been impressed with all the images I've been seeing. This is one of our images of a double star system that we were measuring the separation and position angle on. So this is just so you can get a sense of what they look like. And I'll tell you about the telescopes we use in a moment. But yes, I co-founded about 6-7 years ago now, the Institute for Student Astronomical Research. I realized we need to update our website to this summer's program, which I'm really excited to run. I usually run the program 3 times a year, but with actually, and COVID isn't a problem for us because everything we do is online. COVID is a problem, but we can still run our programs and use remote telescopes and collect our data. So we have a whole, our website. We've developed a sort of a handbook, Small Telescope Astronomical Research, which goes through the whole process of research, how to select a target, how to collect and analyze data, and analyzing data and interpreting your data is, really key to a lot of this, but then also how to write up for publication and how to present your data, because the programs that we run, the research seminars that we run, students write up the results for publication in the Journal of Double Star Observations. And so they learn the writing process while doing this. We've also created a whole Canvas course that we can just give to teachers and say, here's all the material. Here you can run an 8-week or 12-week or 1 semester seminar. And during that time, select a target, use telescopes, collect data, analyze data, and write up your results for publication. This is really transformative. Very rarely in our educational careers before we're getting our PhDs do we actually publish papers. And here's a chance for high school students and community college students to do that. And so it's kind of cool for me to see this process of, I start with, our first meeting with students and educators, and we have these great mixes where there will be high school students, college students, professors, all working together in teams to collect data. And they just learn how to write papers. And then this is an example from November 2020. All the articles in the Journal of Double Star Observations with stars next to them from that issue were from student teams. So they're really contributing to the science in addition to learning about the science themselves. They're really making a significant contribution to this very small area of research. We have partnered with the Las Cumbres Observatory Global Telescope Network. We're one of their education partners or global sky partners. So we get access. We have like 50 hours a year, which is plenty of time for double star pictures, to their network of 0.4 meter telescopes around the globe. So that's really exciting. So no matter what double star we're interested in, whether it's in the northern and southern sky, we can access it. And that's exciting. And we've also put together robotic telescope conferences about the student research and education. And one of my favorite pictures from all of these conferences where we're sort of saying, hey, bringing together the telescope people, the educators, the students, and everyone, what are we trying to do in astronomy education? And by the way, I wanted to tie this back to all the presentations I watched earlier in the evening, where everyone just, there's this draw in astronomy, whether it's rockets and crazy water rockets the size of the universe and whatnot, or images of the sun in the different filters or whatever. There's just this draw in astronomy, and bringing this to students is really a kind of a way to help them embrace science and learn the process of science. But this is one of my favorite pictures because this is actually the founder of the Las Cumbres Observatory Global Telescope Network meeting the founder of the Skynet Telescope Network, two of the biggest global telescope networks, the founders of them meeting each other and saying, oh my gosh, what can we do? And here we are this was a conference in Hawaii, which is a great place to have a conference, looking up at Mauna Kea. We also have a lot of international partners. Michael Fitzgerald from Australia has been sort of key. He runs a huge number of high school astronomy research programs, and we've been partnering with him and many other people. So it's been really an amazing experience. I personally study the impacts of these research programs on students, and we can see, if you just look at the changes in mean, this is measuring self-efficacy, students' sense of, I can do this, I can use telescopes, I can learn astronomy. And if you look at the increase from 55 to 65, that's a huge increase this was out of 80. And so we're able to measure these changes with students having access to robotic telescopes. And then this was giving this presentation at a conference in Australia. We're really trying to be a part of a global community. Scott mentioned Mount Wilson. We take students up every summer to Mount Wilson, and they actually get to use the 100-inch telescope or the 60-inch telescope to collect data and do research projects there. And one thing that sometimes it doesn't actually get lost amongst all of you, I've noticed with the poetry we heard and everything, but the human element to science. One of these students, the first author on the paper, was so inspired by Mount Wilson and her experience up there that she made this beautiful painting of the 100-inch dome. And so there's this amazing connection between the science and the aesthetic of it all, and sort of we have this human connection to the sky that's really cool, that we can sort of touch on in doing research. Scott mentioned we met at the Northeast Astro Imaging Forum or Astronomy Forum. I also bring students who do our research programs, I bring them to these conferences and have them present their research to the greater community. So for example, these are high school students presenting to people at this conference in New York. And one of the people in the audience is a NASA astronaut who's, been on the International Space Station for a year of his life, and they got to meet him and talk, and he asked them specific questions about their research. So they get to be part of the actual community, and then they get to go out and meet the other people in the imaging community, and really great partnerships formed from all of this. So that's really exciting. I brought students onto the Astro Imaging channel, and they got to give talks about the research they were doing, including speckle interferometry, which is a fancier technique of studying double stars. But what an experience for high school students to be involved in this greater community. So that's really exciting. I was then invited to bring this to the International Astronomical Union's Astronomy Education Conference. So here we are becoming, again, part of this global community. It was just amazing where I'm presenting the research that these students are doing in the US, and here there's the Thai Astronomical Conference talking about their student research, and the Russian schools talking about their astronomy research. So it's really an amazing global thing, as you all know. And then What's really cool, and again, bringing this global thing together, this is a student I'm in California. She was my student in Florida. She was in high school at the time. She presented her research at this conference remotely in Australia, where I was excited to see kangaroos and other wild animals. But it was just this really cool thing about bringing, giving these students these amazing experiences. And so we take them from often students who have never had an astronomy course to learning about double stars, using telescopes that professional scientists use, writing and having their writing totally torn apart, to eventually having a paper accepted for publication. This is an amazing experience for students. It's an amazing experience for me, working with all the students and the educators. And that's what the Institute for Student Astronomical Research is about. And I want to thank you all for listening, and thank you for inviting me to talk about it here.
That was awesome, Rachel. That was incredible. I think that have really inspired a lot of the people here watching our program. Instar, and maybe you already mentioned this, but how many years? How old is the organization now?
It's only about 7 years old, I think. Yeah, it's pretty young. And we just sort of said we need to have an organization where we can bring these, an umbrella organization to run these seminars.
And how many students have been through the seminars at this point?
A few hundred.
A few hundred. Okay.
Yeah, a lot. Hundreds for sure. Yeah.
Wonderful.
Yeah. And what's really cool is I'll teach the seminar to, for example, teachers at a university in Idaho and a university in North Carolina, and then they'll go and teach the seminar to their students after I'm done. And so it's expanding. It's going, the reach is much greater than me in the Institute. Incredible.
Well, I have some ideas that I'll talk to you offline about, Rachel, but
Sure.
You've made my gears really start turning. So
Yay.
Thank you so much. It's great to see you again, and I hope
Nice
you're
to see
doing
you.
well. Your energy level is always way up here. So thank you. Thank you again.
Thanks for having
coming
me on.
That's great. Okay, so our next speaker is Jenni BeDell Shelly, and she has been someone that has been watching our program, the Global Star Party, many of our other programs for a while. We are so happy that she has decided to come and give a presentation. She's an astrophotographer. She has worked with the Mark Slater Remote Observatory. She's out in Virginia, and Jenni, thank you again for coming on to Global Star Party.
Thank you, Scott. So I don't really have much of a presentation per se, but I'll just talk about what I've been doing. I've been doing astrophotography for since 2018. I believe I ordered my first mount from Explorer Scientific on Valentine's Day of 2018. It's the first mount was an Exosuit PMC-8. Since then, I've graduated to the G11, which I really like a lot. I've been, pardon?
I said, me too. I have one, and that's kind of my setup that you see behind me back here. So,
yeah, I really like that because it's it breaks down into different modules, and it's easier for me to carry. I weigh like 101 pounds, so it's easier for somebody like me to carry. So, so I do all of my astrophotography off of my front porch or the front yard. I live in a Bortle 7 sky, and I have a lot of light pollution here at my site, which I call Astro Yard. And right now I have a bunch of neighbors. Neighbor across the street has their lights on and the holiday lights still up. I was kind of hoping they would take them down soon, but what can you do? So I do all of my imaging with that, and I've been using the G11. My most recent acquisition is a Meade ACF 10-inch scope, which is quite heavy. I'm still working out the kinks with, making sure everything's balanced properly and whatnot. And this evening I've been working with getting the autofocus set up on that. It has that little focuser mechanism on it, but I bought a Clifford focuser to make things a little easier. Currently tonight, I'm imaging Thor's helmet. I acquired about 10 images last week, so I'm trying to get more data. My view, I only have a view from the south and some partial from the east and the west. There are a lot of trees, so I can usually get, if I'm lucky, 20 images in a night. Sometimes if I get started a little late, I get about 10. Right now I'm using Nina, and it is doing a meridian flip right now. So unfortunately I can't show you anything because the meridian flip kind of overtakes the whole program. I do have, let me see if I can pull that up. I have, with this telescope, I was able to get a picture of Orion Nebula with a different camera.
Okay.
Let's see, let me share my screen. So this is my most recent image. Wow. With that Meade scope. I've been trying to get the collimation dialed in as well, so it's little. The stars aren't as good as I'd like them to be. But that's my most recent one with this scope. Actually, the only
We've got a little bit of a freeze frame going on here.
night.
There we go.
It's really, really cold, so I'm not a fan of the cold. So.
A question, Jenny, is how do you deal with that light pollution?
There's nothing I can do about it other than use filters. This one in particular, I used an Optilong L Extreme filter, and that blocks out quite a bit of it.
Yes. We're lucky to have filters like this today.
Yes, yes. I haven't shot any narrowband with a mono camera with it yet. I have several different cameras that I have in my arsenal. The first camera, which is what I shot this with, is a QHY 168C. I have a 128C and a 600M and a 183M that I haven't even tried yet. I have the Exos 2 PMC8, G11 PMC, and a iExos PMC8. I have a little tiny, Asker 400 millimeter scope that's dedicated to that, and with the QHY 183M camera. And I have an Explorer Scientific FCD 100 127 millimeter that I use also on the G11.
Yeah, thank you. That's great.
And another, I have a Asker 600 millimeter that I use the QHY 600M on. So I use that on the Exos 2 mount. I have yet to, I would like to eventually have all three mounts running at the same time. So I imagine that would be quite a feat. That I suspect I would have to use 3 different computers.
Right.
Let's see. So I think
Maybe get 3 different little NUCs or something to run them and then network them or something somehow.
yeah, I use I have a little Dell Optiplex micro computer that's worked really well.
Mhm.
Actually recently bought another one that I use for my image processing. That's what I have out there right now with a little monitor, and I'm remoting into that.
Right. I'm curious. I mean, when did all this start for you? When does astronomy go back to your childhood?
Not really. I used to look at the stars when I was a kid. I'd lay in the grass.
Yeah.
But that's pretty much it. I got it. I was interested in it. Just one day I was like, well, you know, I'm going to try to take some pictures of the moon.
Mm-hmm.
So that was the very first thing that I took some astro images of. And then I was like, well, I want to try to take some pictures of nebula. So I remember the very first time I took a picture of Orion's nebula. I was just ecstatic. I was just very excited about it. I had my husband out there. I was like, come on. You gotta look. It was just a DSLR and a very cheap telescopic lens. And after that, I was hooked. I was like, I just want to get better and better at it. You know, I'm still learning. I have a lot to learn. You know, I don't really have any background, like, which, you know, are the fundamentals, which I have not done anything with, but star hopping or anything like that. I have one eyepiece. And so I, you know, image, and that's all I do. I rely on plate solving. So one of my goals is to, you know, learn the fundamentals of, you know, with star hopping and whatnot. And actually I have a couple eyepieces, but I don't really use them.
You're mostly astrophotographer. Now, are you all self-taught? I mean, are you working with a group of people, or how did you get to where you are now?
It's just me. I'm, you know, a loner.
Wow.
I'm not, you know, associated with any groups or anything. I'd like to eventually, you know, have somebody in the area come by and or go somewhere and meet up with some local folks in the area. But yeah, it's just me. You know, I've done everything myself.
Wow. I would say you've done very well.
Oh, well, thank you.
You've done very well. So, you know, and you know, it's great that you're sharing your experience here on Global Star Party. And, you know, what do you hope to do? I mean, aside from learning some of these basics, I mean, you could buy like a Dobsonian or something, or just start with binoculars, I guess, you know. But what's your next goal in astrophotography?
I'd really like to go after a very, you know, I got to figure out which target, but in my field of view, you know, from what I have in my front yard, because my backyard, I can't, there's trees everywhere. But I'd like to, you know, go after like a really small, or actually a really large object and do a very large mosaic.
Sure.
I've done one mosaic, but that was with my Explore Scientific telescope. So that's 952 millimeters. And this meet is 2032. So it's a pretty big jump.
Right.
And, just sharpen the saw, learn new skills and processing techniques. I subscribe to Atom Blocks. Horizons and fundamentals. So that's helped quite a bit. And, kind of do it on, a little bit at a time. But yeah, that's pretty much it. Let me quickly share my screen.
Okay.
I don't think my plate solving worked very well. Oh, here it is. Okay. Let's see. So I'm connected to a remote desktop.
Oh, so you're doing live imaging right now?
Yeah, right now I am.
Oh, that's cool.
So yeah, this is a Thor's helmet. I'm still working out see, my stars are a little funky. I think I'm a little off on my collimation. The tricky thing is for me with the collimation, and this was, the very first SCT that I've owned. I'm familiar with the Newtonians because that was actually the first telescope that I bought. It was a Explorer Scientific N208, the carbon fiber. So I'm familiar with, that type of telescope, Newtonian. So it's kind of similar, but I'm still learning on the collimation. But I think, like I said, I'm a little off. But I'm trying to get a bunch of these tonight so I can do some processing.
Right.
So and I have all of my little programs running in the background. My guiding, I'm still honing in on that too. I think it's a balance issue that I'm dealing with. And actually, I'm testing out the beta firmware for Jerry Hubble tonight.
Oh, for the PMC-8, right?
I haven't noticed anything different, so it seems like it's doing fairly well. So I can report that back to him.
He'll be happy. Jenny, for other people that are, also learning about astrophotography and they're doing it alone, such as you have, how would you advise them? I mean, to kind of go along that journey? What would you tell them?
Well, I guess it depends on their learning style, or what's best for them. For people like me, they're like independent and not, don't have the need to be around a bunch of people. Join a bunch of Facebook groups, listen to the, Explore Scientific streams. There's a lot of, good people that you get exposed to and you learn something from them. And I take a bunch of notes. I probably have about 3 or 4 notebooks here in front of me that I take notes. Don't be afraid to fail because you will.
Sure.
You'll fail.
That's how you'll learn.
Don't be discouraged. Keep at it. If you're persistent, you'll get better and better. And, like I said, I have a lot more to learn. But, I'm happy to share my images with friends and family. So this is really the first time I've really, other than Facebook friends and family, I haven't really shared any of my pictures with anybody. Well, I did enter the one contest for Explore Scientific.
Oh, there you go. That was a step. But it's great to have you on. We have, as you know, Jenny, we have a global audience, and we are fortunate to have you on. And I hope that you feel compelled to come back and share often with us. So I think it was great.
Yeah, thank you for having me. I appreciate it.
Thank
And
you.
thanks, everybody.
Thank you so much. That's great. Okay. Well, up next, we go down to Argentina. And we've got Maxi Falieres here. And I see Nico the Hammer in the background here. But Maxi, thanks for coming on to a Global Star Party. I think the last time we saw you, the last time I saw you, you called me. You called me. We had a video call. And you were doing some work down there. You were on vacation, I think.
Yes, I was in San Luis province,
right,
in Potrero de los Funes. And I was watching the sunset, taking pictures with the mountains, and yeah, it was a beautiful look. And well, that's why I call you, because I want to share with you that moment in that place. And you showed me that it was amazing. It was the sunset too, where you been.
Right.
So
we were having the same sunset, two different hemispheres. Yeah, it was cool. It was cool.
So, well, thank you again for inviting me. And hola, Nico. ¿Cómo anda, chabón?
Hello, how are you? Hi, Scott, Maxi.
Hey,
hi, everyone.
Nico, how are you? Yeah, it's great to see you too.
Well, the last weekend, finally we can met with Nico and other persons in Alberti to do some astrophoto, to do observations, and of course, having a good time, chatting, laughing, making jokes, and you know, we thought it was like a lottery because we had some bad weather that Saturday at the afternoon. It was raining, and then the clouds goes out, then they cover up again. But the local weather says at the night, almost 11 p.m., is going to get out of clouds. So we cross our fingers and wait for that. So let me share my screen.
Okay.
Okay. So we have here some pictures that we took. Well, almost all that it was from Alan Gedin. This is mine that I took with my cell phone. Here's Marco Santa Rosa. And here's the cars, and you can see there's a lot of clouds, and this type of clouds, they will have some rain, but here up is the moon, the crescent moon, and you can see how it looks like in the southern hemisphere when it's a crescent. It's like when you see different way. And of course, here is the sunset that we have behind the trees. And well, this picture was taken from Alan Gedin with his, I think it was with his phone. I don't remember.
Wow.
And you can
I
see.
like to see clouds and stars. Yeah, I think it's cool.
Yeah, and also if you have some city behind you or near, they illuminate the clouds, but the sky is still dark, and that's the kind of darkness or contrast that makes it love that pictures. I think here is Nico with his telescope. I don't remember.
Yeah, feeding up the mosquitoes.
Yeah. There was a lot of mosquitoes. Here's a picture of the moon taken by Alan Gedin. He was another person who was in the GSP a couple of months ago. Here's a picture of the team that night.
Yeah.
Here's Alan, the tremendous scope of Nico. Here's Nico, here's me, here's Jose Luis Sanchez, and here's a friend of Nico, Rodrigo, I don't remember his last name, Rolo, for the friends. So we take the picture for, I think it was 5 seconds, and you can see here, here's a little defocused, but the shiny stars, it shows up. Here's Alpha Centauri, Hadar, and then here you have Omega Centauri, the double cluster.
Oh, yeah.
It looks like a star.
It looks like a star. It does.
And here you have the Southern Cross, the Churchill box, I think it called in English, and well, the rest of the region of Carina, and here's an auto selfie of Alan Gedding with the scope of Nico. Here's the place that we've been. Here's the school. We have the letter that says is getting rebuilding and restoration. So we have a really good night where he's the hammer time with Nico.
That's right.
So well, this is from other pictures taken with Alan. And well, for me, I was taking pictures. I want to do some pictures of some kind of galaxies. I bring all my stuff. I have a huge headaches. Nico was a witness, but with almost from the polar alignments. But then I say, okay, let's take a con and start taking pictures. So some place that I've been, it was in GNC 2442. This is near in the Great Magellanic Cloud. I think the constellation was Pez Volador or Flying Fish, something like that.
Yes, it's Volantis, right?
Volantis, yeah. And here's the stacking of the place.
Oh wow!
And
look at
it was
that.
a really funny night because we was observing with the Dobson the same galaxies while Maxi was taking pictures of that galaxy. It was a really nice night.
A really clear night, and also you can see this kind of S letter.
Oh yeah, is that in Fornax?
No, it's in Volantis,
okay.
near of the Large Magellanic Cloud, and there's a lot of galaxies too.
Look at that! They're everywhere.
The annotated picture. Here's the same, but you can see we have a lot of PGC galaxies of the catalog of PGC. Here's one NGC, and here down, here's another one, almost there, and here in this place, they are really far away, really far away, and I don't know what could be this. Because I see it in all of the pictures, but it doesn't have the annotated place. I really don't know. So I continuing taking pictures. I want to do some black eye galaxy, but I only did maybe 6 pictures of that place. This is only one single shot of 3 minutes, you can see the
Nice.
the galaxy is really. Let me reset the histogram and that stretch, because you can start able to see the huge cloud inside of this galaxy.
Right.
And this is only one single picture. And well, I didn't process this. It's only 6 pictures. It doesn't enough, but maybe it was practicing and enjoying the night. And then I went to the antennas galaxies. This is near in Corvus, but I don't remember the region. And this is the finally picture that I get. Let me
wow.
This is the 2 galaxies that crash too many millions years ago.
Yes.
But you can see the shape that they start to have. When I showed this to my mother and my wife, they say it looks like a heart. And
Right.
that you can see this
Oh yeah, a
dust.
stream of stars coming out.
I can even imagine how many stars and planets, and I don't know, there in this arm and also in this one.
Right.
And what happened then? Maybe they still floating in the vastness of the universe or not. And some kind of this is going to happen with the Milky Way and the Andromeda Galaxy. We have to crash with them. And also you can see there's this kind of couple of galaxies really far away, and it's amazing. I didn't annotate this picture, but there's another one. And you know, I want to a long time ago, I want to take pictures of this place. I did it with the DCLR last year, but I didn't like it. So this time I have my revenge.
Revenge imaging.
Yeah, astro imaging. So to get finally, when Nico goes to bed, Alan 2, Jose Luis 2, I stay out having a really good time, but really cold because we have some water in the in our tables and scope. We have a lot of humidity, and the condensation was huge. But I say no, I have to continue in taking pictures until the dawn. And I did pictures of M83, and let me share the result. Well, this is, let me, here's the galaxy of M83.
Which telescope did you use for this image?
I only have right now my 8 inches f4 telescope Newtonian. I think that I have to still practice the collimation, but anyway, I went to do some practice, see the field of view, see the colors, and this is only 14 images of 3 minutes until the dawn. And also I have the secondary mirror. It was covered with no dust, humidity, but I bring my dry hair fan and put it through the telescope to get it dry. Here's a lot of galaxies too. They're really far away, and these two, the they are beside of the
Right.
galaxy that's amazing. And
You can see structure there too.
yeah, this is a really huge galaxy that you can see a lot of gas and dust and the structures of all this place. I did this last year with the QHY monochrome and some LRGB filters, but this time I did with the ZW MC 533 color camera, and only, like I said, 14 pictures stacking. So, well, this is my presentation. I hope that you like it.
Yeah, of course.
I'm really glad to came back. I see behind you, Scott, there's a lot of telescope and
a couple.
Yes,
a couple.
There's more in the next room. There's a lot more.
That Doctonian has my name.
Yes. So, Nico, it's good to have you on here as well. We've had a good time on our 82nd Global Star Party. It was really cool to have a lot of new people on, that had not presented before. I love seeing images from you and from both of you guys. You're always pushing the limits of what can be done with the equipment that you have. And I think that's really inspiring, so when somebody exclaimed that, man, I wish I could make an image like that, so, I think
I wish also too that in the past, and I'm still thinking of that, because you don't have that limit. Oh no, sometimes I realize, I don't realize what kind of pictures I am doing, and also maybe they are not very perfect, but you can still continuing, and there's no end. You always start learning and practicing, and you really enjoy that kind of travel in this experience.
Yeah,
that's right. And sharing, I think that sharing this passion is the important thing, because you learn, you share, and you inspire some other people that maybe has a little telescope and he thinks that he can't do astrophotography or some investigation. And I think the sharing is really important, and that's why I love the GSP, because I love to hang out with you and also to share the experience with all the people.
Absolutely. Well, the audience loves it as well. I think that the very act of getting ready to share, or the very act of doing outreach, like when I do these programs and stuff, there's times I'm scrambling. I'm trying to get things done. I've got somebody walking in my office. There's a zillion things that are going on, and but just getting myself ready to do some presentation and to work with other people like yourselves. That's just, it's wonderful, so I think it's very cool. I think it also helps us that in our own journey, that we're kind of organizing ourselves enough to give some information to someone else, so So any of
Right.
you watching out there, I'm very happy to have you give, if you've never given a presentation before, very happy to have you give your first presentation on Global Star Party.
Yes.
So
Once
gonna find a
I
good group
read
here.
that when you teach something, you learn more, and
You do learn
it's,
more.
it's real. Yeah.
It's like you're forced to,
Yes,
so,
you force
right?
yourself to keep learning and reading and trying something new is really good.
That's right. Well, that's wonderful. So Nico, what's been on your horizon? What have you been doing? Have you got new images or?
Well, as Maxi says, the weekend we went to Alberti to feed up the mosquitoes, but I bring only my Dobson because when I go to a really dark place, I love to enjoy observing and watching the sky. I really love that. And tonight I am here in my patio, but with my 6-inch Newtonian with my equatorial mount, I am trying up a new set of RGB filters. So I am taking some images and learning and sharing with you.
Right. Well, that's awesome. That's awesome. Well, Maxi, Nico, thank you so much. I want to thank all the presenters that are still watching and from our broadcast or still with us here on Zoom. And it was a lot of fun. And we're going to do it again. Of course, next week is the 83rd Global Star Party, and it is the birthday of Galileo. I mean, so the guy that started all of this,
I have something special for that.
Something special. That's right. So he, his life is interesting. The more I read about Galileo, the more I find out about kind of the complexity of his life and what he was trying to do and all the rest of it. He is, I think if we could meet him in real life, we would see that he had many sides to him. I think he was kind of a complex guy, but brilliant and driven. And so, he is definitely someone that we owe a great debt of gratitude to for pushing the limits as he did. He wasn't the only one trying to do it, and he wasn't the only one that did do it. But I think that he would be counted among the best of the astronomical community. Not only from a historical standpoint, but from if he was alive today and the kind of mindset that he has and the hard work that he would do to stay at the top of his form. So, so anyhow, and I want to thank the audience for all the interesting chats and remarks, and for joining in and for helping us share the Global Star Party experience. And until next Tuesday, I'm gonna wish you clear skies, and advise you, just like my friend Jack Horkheimer would always say, is to keep looking up. So thanks, and
good.
Thank you, and good night. Good night. Thank
Good
you,
night,
Nathan.
guys.
Bye-bye.
Thanks for having me.
Thank you. Next time, please.
I'll make sure of it.
Okay.
Bye.
All right. And away we go.